In our today's video, I will be taking you through TV Mathab Mock Examinations 2026, Uganda Advanced Certificate of Education, Principal Mathematics Paper 2. Hello everyone, welcome to TV Mathab. For those that might be here for the first time, TV is my name, and you are highly welcome to TV Mathab. Please consider subscribing. This is the right channel where you will get everything that you need in mathematics. If you are in O level, you are in A level, you are at the university, this is the right channel for you. For those that are preparing for their mock examinations, the candidates, Senior 4 and Senior 6. Please, you don't need to miss any of our videos. For those that are in Senior 6, very many videos have already been uploaded at TV Mathab. If I can take you through, when you come to TV Mathab, we have already discussed about Chieteka mock, and I hope you have already watched this video. So in case you have not watched this video, please go to TV Mathab, then look for the mock that is Chieteka mock for A-Level Principal Mathematics. That is paper 1, and for paper 2, we are yet to come to that. It will also be uploaded very soon. So please make sure you subscribe to TV Mathab so you shouldn't miss any of our videos. So that is Chieteka joint mock. There are other videos that have been uploaded to help you in your revision. This is Kamasa mock. In case you have also not watched this, please go and check for these videos. Make sure you are able to attempt each of the items that we have discussed. Let us not discuss an item from TV Mathab and you find the same item in the paper and you fail. For sure, that would be your own blame. So I will have done my work. So please go and check for these videos before you enter your examination. So there are a lot of other videos that have already been uploaded regarding on different items that you need to respond to. We have talked about the structure of the papers. We have talked about everything that you surely need to pass your A-Level mathematics. So this was a mock paper that was from TV Mathab. That was Principal Mathematics Paper 1. And now we are coming to Paper 2. So you can see that at TV Mathab, surely when you fail, then you should be able to blame yourself because we have surely done all that we can to make sure that you get access to different items, to different responses. So please check for all our videos, go through these videos here, and go into the paper with all the confidence. So that is about TV Mathab. Please make sure you subscribe to this channel so you cannot miss any of the videos that will be uploaded. So this is the paper that we shall be going through. This paper, we shall be looking at it as a group from the TV Mathab community. So for those that are serious about improving their grades, there is a WhatsApp group that we already have. That is the TV Mathab WhatsApp group. So in case you want to improve, your grades, please join this group. This paper that we are going to discuss will be discussed together with the students in this group. So it means you are missing a lot if you are not already part of this group. For those that are already in the group, they know how they have benefited from this group. Joining it is completely free. And if you want to join it, I will put the link in the description. Also, you can come to our website. This is our website. And you come up to the end. You come up to the end, or else you can press here on the top where you have community. So it will be able to bring you to our community. We have a YouTube, WhatsApp channel, WhatsApp group. You can join us on Facebook. You can join us on Telegram. So all these groups here, you can surely connect with other students. So this is the WhatsApp group. It's about the TV Math Hub group, and please make sure you are part of it. So in case you are interested in different resources from TV Mathab, when you come to this website, you'll be able to get the unique papers, the resources that you need, the quality materials that you need. There are those that might need online learning, that is one-to-one. Please also feel free to give us a call. Then for those that are interested in obtaining different materials from TV Mathab. There are some of the materials that are sold. So if you are interested in my premium math materials, feel free to come to our website. Then you can buy any of these according to what you need. So for anything regarding mathematics, please feel free to come to our website and you'll be able to get whatever you need. So let us look at our today's mathematics paper.
Yes.
I want us to really respect time because we have a lot to discuss, and maybe we can give a few minutes. Within the next 3 minutes, we can start. So please, when you reach, you try to mute such that we should be in position to communicate to each other. And in case you have anything that you would like to put across, maybe it is a question, maybe you have any information that you would like to pass, you can simply raise up the hand. The option is there, or else you can try to unmute and let us know. I see Bruce, as if your hand is up. You can let me know. Yes, please.
Yes. Good evening, sir, once again.
Yes, good evening to you. How are you? Yes. How are you doing?
Sir, the other time you promised us that you are going to upload the other recording that you had on the device, on the Google device, but you didn't send it.
Oh, okay. Thank you for the reminder. I was totally too occupied and I think I forgot, but after this, I will surely put it.
Okay.
Actually, we have already gone through all the items, so I will put everything there.
Oh, thank you.
Okay, please. Yes, Trevor.
Good evening, sir.
Yes, good evening.
Hope everything is fine.
All is well.
Yeah, but I was just thanking you for this great job. It really helps us a lot and being of great impact.
Thank you.
May God continue blessing you.
Amen. All right.
And I have one query. Because I'm new in the group, I've just been following on YouTube.
Yes.
So I'm asking this one, the revision session take every day or there's a specific timetable?
No, the revisions like this are generally for those that are in a premium class. So it is actually this is a free class. So I decided to give it out once in a while. But for those that are in a premium classes, we normally meet over the weekdays and over the weekends.
Oh, okay.
Yes, please.
Thank you so much.
All right, please welcome. So everyone, we shall get started with our today's presentation. Today I want us to look at what we call the mock that has been specifically prepared by TV Mathab, and this will be helping us on how we are supposed to respond to the items that will be set in mathematics. So I have already discussed on YouTube, for those that have been following, we have already discussed that paper one. We discussed paper one, and maybe in case you haven't watched that, you can go and check for some of the videos where we were looking at the TV Mathab mock for paper one. So that one is fully discussed. You can go through it on our YouTube. We have also looked at the pre-mock for Kamasa. For those that might have seen that and watched that, you might have also got a hint on what is supposed to be done. And we have also looked at the Achieteka mock. So we are trying to look at different papers, and if you have been following well, then at least you know where to begin from. So without wasting time, I want us to go through Principal Mathematics Paper 2 together, and if possible, we can try to look at all the items within the 3 hours that we have specifically prepared to be here. So in case I'm moving at a very high speed, you will try to forgive me from that side, but I shouldn't wish to leave anyone behind. So in case you are not understanding some of the things, feel free to let me know, such that we all move at the same pace. Okay, so the instructions are very important because we have seen different structures for the papers. So it is always important that when you go to the paper, you try to read the instructions to carefully understand what you are supposed to do. But with accordance to the UNEB sample papers that we received of recent, you should have realized that oh, you will forgive me for that. Basically, there was some miscommunication here. So basically, you realize that from the structure that we had a structure where we were having different ways of how the papers will be set. But according to the UNEB structure, you realize that paper 2 will be consisting of two sections, section A and section B, and it has 5 examination items. Section A consists of one compulsory item. Section B has 2 parts, part 1 and part 2, each with 2 optional items, and you are supposed to respond to only 2 items from section B, where you are supposed to choose 1 item from each of the parts. That is part 1 and part 2. In total, you are supposed to respond to 3 items, and any other of the following instructions will be the same as we have always had. So that is about the instructions, but this paper we shall be answering all of the items. So this is section A. The item in this section is compulsory. So we shall go through this item. The item says municipality is planning to improve the water supply system in its administrative center. Since the existing water sources are insufficient, the municipal authorities have decided to obtain additional water from a nearby river, which has a uniform width of exactly 20 meters. The municipal water engineer has been assigned the responsibility of determining a suitable location for installing a water intake pump along the river. To analyze the river conditions, the engineer represents the depth of the river by the mathematical model, which is given by y of x equaling to this, for which we have 0 less than x less than or equal to x less than or equal to 20. And x represents the distance in meters measured from one river bank. The engineer states that the pumping system can only operate effectively if the cross-sectional area of the river is at least 145 meters squared. According to his calculations, the given model meets this required minimum area. During a meeting with the municipal authorities, the engineer explains that by taking depth measurements at intervals of exactly 5 meters from the river bank and applying an approximate integration method, he can verify that the river model gives the required minimum cross-sectional area. He can verify that the river model gives the required minimum cross-sectional area. He further explains that the same condition can also be confirmed using an exact integration method. For the pump foundation to be constructed safely, the engineer requires the river depth at the installation point to satisfy y of x is equal to 8 meters. He informs the authorities that by taking 4 meters from the river bank as an initial estimate, he can determine the required position of the pump using an iterative method. The position obtained should have an error tolerance not exceeding 0.1 meters to allow stable installation. The municipal authorities require evidence that the proposed river model satisfies the minimum area requirement using both the approximate and exact approaches. They also require the precise location where the pump should be installed to achieve the required depth. And the task is provide proof needed by the municipal authorities. This should be needed by the municipal authorities. Then 2 is to determine and advise the municipal authorities on the exact distance from the river bank where the pump should be installed. So that is the item that is from that is from numerical methods. I hope you understand that section A will be having one item which is compulsory, and this item comes from what we call the numerical methods. So you expect to be dealing with errors, to be dealing with flowcharts, numerical methods, all that. So basically, that is what you need to expect from item 1 for paper 2. Now, let us look at this given information. So we are given that a municipality, is planning to improve the water supply system. So when you look at what we are given here, you are asked to provide the proof needed by the municipal authorities. So you need to look at which part talks about that, and that should be the part that you should be considering first to help you in answering this item. Now, looking at that, we are told that since the existing water sources are insufficient, the municipal authorities have decided to obtain additional water from a nearby river, which has a uniform width. So this is the width of the river. And the municipal water engineer has been assigned the responsibility of determining a suitable location for installing the water intake pump along the river. They are saying to analyze the river conditions, the engineer represents the depth of the river by this. So this is the expression that is representing the width of, that is representing the depth of the river. And the values of x are from 0 to 20. And x represents the distance in meters that is measured from one river bank. Now they are saying the engineer states that pumping system can only operate effectively if the cross-sectional area of the river is at least this. Meaning that if you get the area, and the area is at least, when they say at least, that is greater than or equal to 145 meters squared. Meaning that the value of the area can be greater or equal to, this is greater or equal to 145 meters squared. So this is the area. So the area should be greater or equal to 145 meters squared. That is the given condition. Can only operate, you can see the condition is that the pumping system can only operate if the area of the river is at least this. Meaning that if we are to talk about uh, the response to this, then we might talk about something to do with the area. And we see if the area that we shall obtain will be at least 145 meters squared. And they are saying, according to these calculations, the given model meets this required minimum area. So meaning that the model that we are given should be meeting the minimum area, and the minimum area is of course 145 meters squared. Now they are telling us that during a meeting with the municipal authorities, the engineer explains that by taking depth measurements at intervals of this, so you are taking depth measurements, but remember the depth of the river is represented by this. The depth of the river is represented by this, and when you take the intervals of 5 meters from the river bank and apply an approximate integration method, he can verify that the river gives the required minimum cross-sectional area. So looking at this, it should be telling us what we need to do first. So it means we need to look at an integration method which we can use to get the area, and that area should have the minimum value, which is this, meaning that the area should be greater or equal to 145 meters squared. That is one of the methods. That is the approximate method that they are talking about. Then there is another statement. He further explains that same condition can also be confirmed using an exact integration method. So from here, we shall also be able to talk about the exact integration method. So, and you also confirm whether the area will be greater or equal to 145 meters squared. Now they are saying for the pump foundation to be constructed safely, the engineer, okay. So that one, we shall talk about that. But for part 1, where we need to provide the proof needed by the municipal authorities, these are the proofs that we need to talk about. 1, by looking at the first method, where we are using an approximate integration method, and 2, we look at another method where we are using an exact method. And those are the proofs that will help us to confirm that the area is really greater than or equal to 145 meters squared. So that is basically what we need to talk about. So let us see how best we can respond to this item here. So looking at the response, we need to look at the verification of the river cross-sectional area. That is our major focus. So we are saying the depth of the river is given by this, as we have seen, y of x, which is equal to that. That is the given information. So one, the cross-sectional area of the river is the area which is between actually the curve and the river bed. So we are having this curve here that is representing the depth, and to get the cross-sectional area, then we are basically looking at the values of x moving from 0 up to 20. So it means the cross-section area can be obtained by getting or by integrating from 0 to 20. You know, integration represents what we call the area under that given curve. Now, they are telling us that the required minimum cross-sectional area is 145 meters squared. So we are having this information that the engineer needs to verify using these two methods. One, the trapezium rule. Trapezium rule is the approximate method that we shall be using. The approximate method that we shall be using will be for the trapezium rule. Then the exact method we shall be using is the exact integration. I have a question here, so you can put the question up. Martin, I see your hand is up. Maybe you have some question. Okay. If you have a question, Martin, please, you can unmute and let me know. I also see Bruce, your hand is up. And in case it is not there, then we can surely proceed. Okay.
It was a mistake, sir.
Okay, no problem then. Okay, so let us go on. So this method here, remember we have to use two methods as we have seen. One is the approximate integration method, and that integration method for obtaining the area where you are using integration is actually what we call the trapezium rule. And the exact method they are talking about, that the same condition can be confirmed using exact integration method, and then that one there is the exact integration. So that is basically the information that we are given. So I hope everyone at the moment knows how to use the trapezium rule. So they are telling us that the river width is 20 meters, and the measurements are taken after every 5 meters, and that implies that our h for that case will be equal to 5. Now, if that is the case, then let us look at the depth values that are calculated using this y. Of course, as we know that whenever we have x here, we can easily get the corresponding value of y. And when you look at the x values are starting from x equaling to 0, and there is an interval of 5. So from 0 to 5, then to 10, then to 15, and lastly to 20. So those are the values of x. Those are the values of x. Now, with the values of x, then you need to get the values corresponding to y. And remember that our y is given as y is actually given as 12 minus 0.12 into x minus 10, which is squared. So that is what we are having now. From x values, we can easily obtain the y values. So for y values, we shall start by putting putting where x is, we put 0. So for x equaling to 0, then we shall be having y of 0. So substitute where x is, put 0, and that is what we are having here. So when you do that, then it means you'll be able to get 0. So meaning the y value that will be corresponding to x equaling to 0 will be actually 0. We normally have the first value and the last value in this column, and again those that are in between, we put them in this column. Now you will need to go to y to x equaling to 5 and get y of 5. So what will be y of 5? Substitute where you have x in this expression, put there 5. So when you put there 5, then you should be able to get 9. So this value 9 will be placed at that point. You will do the same for x equaling to 10. Substitute where there is x in this expression, put 10, it becomes 0. So you'll be able to remain with 12. So you should be able to remain with that. Then you go to x equaling to 10, that is done. X equaling to 15. So for x equaling to 15, you get y of 15. That will be 12 minus 0.12 into 15 minus 10, which is squared. So that should be able to give us 9. You confirm those values with you there. So that should also be in a position to give us 9. And lastly, we shall put x equaling to 20. So when we put x equaling to 20, you should be able to get 12 minus 0.12, 20 minus 10 squared, and that value will be 0 as well. So you confirm whether you are getting the same values. So from here, we shall be able to have the sum. The sum here will be 0. The sum here will be 30. Then after getting that, now you can substitute within the formula. So we are given, or we know that the integration from 0 to 20 of y, which y we had it here, which y we had it as 12 minus 0.12 into x minus 0.1 minus 10. Everything squared, dx here, the whole of this should be able to give us, should be approximately equal to, if you remember very well, the formula. Can anyone state for us the formula for when you are having this? What is it supposed to be? I want to call this one y naught, y1, y2, y3, and y4. Can someone tell us the formula for the trapezium rule that we can substitute in? Let me get one person. Yes, please.
Yeah, I think we are going to use the there's a half.
It is a half.
And height.
Height.
In open the bracket that you said.
Yes.
Y 2 times the y naught.
Which one? Y naught?
Times the
times
2 this sum of the y naught and y.
I think your network is a bit unstable. I've not got it well.
What's that?
Oh, network. Can someone let us know? Let me see. Yes, Bruce.
So what we do there, we say that
yes,
a half,
yes,
then times h,
yes,
then open brackets,
yes,
y naught plus yn,
y naught plus yn. So
yes,
for our case, yn for our case is this.
It is 0.
Y4. Okay. That is like this is our first one. This is our Then plus.
Then plus 2.
Plus 2.
Yes, open brackets, y1 plus y2, then plus yn plus 1.
Okay, so for our case, yn minus 1 is 3.
Okay.
So that is the trapezium rule. Thank you. So that is the trapezium rule we shall be using. Another thing before we use this, the mistake that I have realized that majority are doing here, people are getting, some of the students are getting this value and they subtract this. So you find someone is getting 12 minus 0.12 and we'll say that this will be actually 12 minus 0.12, that is 11.88. So you find someone is having 11.88 into x minus 10, which is squared. That is what some students are doing there on this number. Y of x is equal to 12. They are getting 12 and they subtract this value. 12 minus 0.12. Please, that is wrong. This 0.12 is multiplied here, is multiplied into this expression. So don't subtract 12 with this. There is a reason why some of the expressions are not written direct, because that is the mistake that we expect some students to be doing. So because they see this is 12 minus, they be like, oh, I can easily simplify this one and I simply have this. Please, this is wrong. The reason is there is this subtraction and this value is multiplied within this. So you cannot do that. So please be careful there. So this is the formula that we shall use. So you realize that this one and this already gave us our sum, which was 30. So having y1, y2, and y3, then it means here you will have 2 times 30. Y0 and y4 is the sum that we are obtaining here, and that sum is 0. Then we have a half times h. H is the interval which we have here, and that is 5. So that is 5. So we are having times, and that is 1 bracket there. So please make use of those brackets. Make use of those brackets. So this will be giving us a half times 5 times 60. So of course, we shall be able To obtain from there, we shall now be in position to obtain what we call the So there is a value. Okay. So we shall be able to obtain the value of the area. So by 2 we shall be able to get 30. So 30 times 5 we shall be able to get 150. So the area is approximately equal to 150 meters squared. So that would be the area. That would be the area that we shall obtain when we are actually using the approximate method. So the approximate method will give us this area. And I hope everyone at the moment knows how to use the trapezium rule. So that shouldn't be a problem to majority of us. So having gotten that value, then you need to confirm with the given condition. Remember, the condition was that the cross-sectional area of the river should be at least greater, that is, at least greater than 145, or it should be at least 145 meters square, meaning that the area should be greater or equal to 145 meters squared. So looking at what we have obtained, you realize that the trapezium rule, that this value here is greater than this, and that means that the trapezium rule confirms that the river has sufficient area, because that is what we needed to talk about. Because they are saying that the engineer states that the pumping system can only operate effectively if the area of the river is greater or equal to that value. So from that we have obtained, should be able to give that conclusion. Then there is another method that we were talking about here, the method of the exact integration. So we need to look at exact integration of this. So to obtain the exact area, we look at the exact integration. We look at the Andrew Rupanga, can you please unmute? Okay. So we need to look at the exact area by using integration, and that is what we shall. This is what we shall be doing. We need the area by integrating from 0 to 20 y of x dx. So we shall be integrating y with respect to x. Y is given as this. That is 12 minus 0.12 into x minus 10, which is squared. So from here, you can simply split this and integrate 0 to 20 of this one here, that is 12 dx, because this can be written as the integral of 0 to 20, this 12, then dx minus 0.12, 0 to 20 of this one here, that is x minus 10, which is squared, and we have a dx. So you can easily integrate this. So from here, we have very many ways of how we can easily integrate this. One, someone can easily integrate this at once, because you can easily integrate 12, and I think someone should be able to give us the answer here. What do you get when you integrate 12 with respect to x? Yes, someone who can give us the answer. Yes, one hand is up, Bruce.
You get
You'll get 12x, but we have limits from 0 to 20. Okay, go on and do this. 102. How do we integrate the whole of this?
the whole of it.
Yes, at once.
Or then maybe let me first substitute, because if I get them, go step by step. Yeah, I have been.
You are getting
240.
200?
12 times 20.
I'm not getting you where there. Yes, Ruboa.
I'm getting at once, yeah?
Yes, I want us to do it at once.
I'm having 12x.
12x. You are first simplifying this? Okay, you are having this.
Everything at once.
Okay, go on.
Rho of x
Yes.
minus 0.12 open brackets
Yes.
x cubed
X cubed
divided by 3.
divided by 3
Yes, then minus 10x squared,
minus 10x squared
then minus 100x
minus 100x.
close brackets.
Okay, thank you. Okay, minus 100x. Let me put it here. So any other? You said 0.12 2x to the power 3 divided by 3 minus, was it 10x? Remind me of the value you had got, Rubowa?
I had got x squared, that is minus 10x squared.
Minus
And then
10x squared?
Yes, minus 100x.
Minus 100x, okay.
Yes, after expanding. Yeah.
Okay. This is 1. 2, I need another method. There are various ways how we can do this. Fanny, your hand is up. What are you saying? Fanny. Okay, possibly let's go on. Now, this is one way. It means for Aruboa, you first expanded this. You first expanded this, which is okay, and you got this. So you put the limits from 0 up to 20, which is okay. That is one way. The next way is after when you are to, I'm looking at integrating 0 to 20 of x minus 10, which is squared. And this is with respect to x. Now, when you look at this expression that you have in the brackets here, you realize that actually this value here, the power of x is power 1. If x is to power 1, then simply integrate this. Because, okay, there is a coefficient here, 0.12. Simply integrate this at once. So how do we integrate? Increase the power by 1, divide by the new power. As simple as that. But that one only works when the power of x that you have in the brackets here is 1. So if it is like x squared, don't do that and say, hey, but so and so said here, we simply increase the power and divide by the new power. So that one only happens when the power of x is 1. So if the power of x is 1, there is no any other x here. So you can easily integrate this by simply increasing the power and dividing by the new power. That one will be easier. That one will be a bit easier. So this is what we shall do. This is also okay because we first expanded x minus 10 squared and got this as x squared minus 20x then plus 100 and then integrated this. On integrating this, then he got x to power 3 divided by 3 minus 20x squared divided by 2 plus 100. I think this should have been a plus, not a minus. Plus 100 of x. This is how he obtained this value by first expanding, which is also okay. But as I said, the easier way is when you are to expand this. That is okay. That is one way. But another way, since the power of x is 1, simply increase the power by 1, divide by the new power, and you will have that one solved. So this is what we shall do. You have integrated this 12 with respect to x, so that will be 12x. That will be 12x, and don't forget the limit. So we shall have that as 12x from 0 to 20 minus 0.12. Then, as I said, let me increase the power of this by 1 divided by the new power. So that will be x minus 10 to the power of 3. I divide by 3. I put my limits from 0 to 20. As simple as that. But that one only applies when the power of x that you have in the bracket is power 1. So from there, we have this as 12. Put the limits, begin with the upper limit, 20. Then the lower limit will give you 0. So this is what we shall get there. Then minus, this should be able to give us 0.04 into, now put the upper limit, that will be 20 minus 10 to the power of 3. And we shall be able to put a 0. When you put 0, this will be 0 minus 10 to power 3. So this would be able to give us 240. Then we shall be able to subtract 0.04 into this will give us a 10 to power 3, that is 1,000, minus this is negative 10 to power 3, which is negative 1,000 as well. So looking at that, it means you will have 240 minus 0.04 into this, and this will give us 2,000. So someone can get for us that answer. 240 minus 0.04 into 2,000. Okay, so of course we can easily do that. So this will be 80. So you will have 240 minus 80. So I hope you confirm that it will be 160. So this is the exact value, and this will be meters squared. So that should be the easiest way you can easily get the answer. Even if you expand and you do the way he has done here, put the limits from 0 to 20, you should be able to come to this value here. So that is how we obtain the exact value. That is one way. Another way actually you can do is you already have this part, you have this, so you can try to split the parts. So you have the first part as that, which will give you 240, and then the second part, actually the second part, you can first begin by letting this, by letting u to represent like x minus 10, and then from there, it means if u is representing x minus 10, then it means dx will be equal to 1, which actually means that du is same as dx, or dx is equal to du. And then if you let, then it means you need to change the limits. There you must change the limits. So when you change the limits, you should be able to get u as negative 10 and u as a 10 when you put x equaling to 0 and x equaling to 20. Remember, u is that. So when you are changing limits, you are removing limits from x, which were 0 to 20, and u is x minus 10. So you're having 0 minus 10, which is negative 10, 20 minus 10, which is 10. So it means where there is x, you put negative 10. Where there is 10, you will, where there is 20, you will put 10, as we have got here. So there you are using, you are changing variables there. So it means where there is this value, this expression, x minus 10 in this expression, then you can simply put there u. So that's why we have u squared, which you will put and integrate. So when you integrate, you'll be able to get this, put your limits, and you should be able to get it. So likewise, you will be able to come up with the same answer. So there are various ways of how you can deal with that integration. So clearly, we can as well see that the exact method also confirms that the river meets the required condition, and which condition was saying that the area must be at least 145 meters squared. So that would be the first part. So in conclusion, we shall be able to say that the cross-sectional area of the river satisfies the requirement for the pump to be installed, since both 150 meters squared that we got using approximation method and 160 meters squared that we got using the exact method are greater than the required minimum cross-sectional area of 145 meters squared. So that should be our conclusion. Please, whenever you are doing an item, make sure you give the conclusion. That is very important. Part B, we need to look at determination of the pump position. So this is where it starts from. For the pump foundation to be constructed safely, the engineer requires that the river depth at the installation point to satisfy, the position must satisfy this. The position must satisfy this. Now, he informs the authorities that by taking 4 meters from the river bank as an initial estimate, so we are given an initial estimate, he can determine the required position of the pump using an iterative method. So we need to look for an iterative method that we can use, and we are given the initial value or initial estimate as 4 meters. So we need to determine the position, and that position should have an error tolerance that is not exceeding 0.1 meters to allow a stable installation. So the municipal authorities require evidence that the proposed river model satisfies the minimum area requirement using, okay. So this is basically talking about what we have already talked about. So basically this is the information that we shall be answering in part 2. And that is for part B. Determine and advise the municipal authorities on the exact distance from the river bank where the pump should be installed. So we need to determine the distance, the exact distance from the river bank where the pump should be installed. And that position should be the position that we shall obtain, taking 4 meters as our initial estimate, and looking at the error, which is not exceeding 0.1 meters. So let us look at how best we can answer that. So the required river depth is y of x equaling to 8. So that is the given, because they are telling us that the river depth to the installation point should satisfy y of x equaling to 8 meters. So this is what is required. Y of x should be equal to 8 meters. But of course, we already know this. Y of x is already known. It is already given as 12 minus 0.12 into x minus 10, everything squared, which is equal to 8. Now from here, you can bring this one to the other side. So it becomes 12 minus 8, and that will give us 4. So you have 4 minus 0.12 into x minus 10 squared, which is equal to 0. So from that, we shall relate this one here, this to be our f of x now. So we want to let f of x to be equaling to this. So when it is equal to this, then we shall obtain the position for the pump by solving f of x equaling to 0 by using an iterative method. So the iterative method we need to use here is the Newton-Raphson method, which I believe you all recall how to use that method. So we are given the first estimate, so we can easily get the second estimate. So from here, we have obtained the f of x. So let us use the Newton-Raphson method, which says that x of n plus 1 is equal to x of n minus f of xn divided by f of x, f derivative of xn. So we need f derivative here. So we have f of x as 4 minus 0.12 into x minus 10, which is squared. So here you need to differentiate. You need to differentiate this with respect to x. You need to differentiate this with respect to x. So how do we differentiate this with respect to x? Differentiate 4 and get a 0. I hope you know when we differentiate a constant, we get a 0. And then what do we have? Next, we shall have negative 0.12. As I said, when you are differentiating, I hope everyone knows that. Even if this one is not to power 1, but you should be able to easily differentiate this. So someone should be able to tell us, how do we differentiate this? How do we differentiate this? Because we have already said when you differentiate 4, you get a 0 minus, how do we differentiate that? Yes, Rubowa?
We shall drop the power on x minus 10.
So use
then
just
we shall
state how
have
it should be.
negative.
Negative.
We shall have negative 0.24.
0.24. Okay, so you have got 0.12 times 2.
Yes.
Okay.
Then open brackets. X minus 10. Then times 1, which we shall leave.
X minus 10, then times 1. Okay. So I hope you have used the fact that you drop the power, then reduce the power by 1, where we shall then with 1, the 2 drops here, we get a 2. We reduce the power for this by 1. We multiply by the derivative of the brackets.
Yes.
But the derivative of what we have in the brackets is 1. Okay, thank you. So this will give us 0.24 into x minus 10. So it means if this one changes and it is x squared, then it means you do the same way as done, but here you must multiply by the derivative of what you have in the bracket. So this is what we shall have as f derivative of x. Now from the Newton-Raphson method, where we have x of n minus f xn divided by f derivative of xn, then this means that for our x naught, that is n equaling to 0, that is n equaling to 0, we were given this first estimate, which
Excuse me.
yes, please. Yes, please. Rukundo Joseph.
Excuse me.
Yes, please. I'm getting you.
Hello.
I'm getting you.
Excuse me, sir. Good evening.
Yes, good evening.
Good evening, sir. I'm glad to be here.
Okay.
But sir,
yes, please.
I'm asking on that formula. I'm asking on that formula of Newton-Raphson. Are you hearing?
Yes, please. Yes, I'm getting you.
Because for us, our teacher told us here on xn plus 1.
Yes, please.
Then equaling. I'm confused here on x.
Where?
Thank you.
I've not picked the question well. Your network was off and on. Yes, Rubawa.
Sir, I suggest that he types his concern.
Maybe.
Otherwise,
On the formula. Yes, please.
I suggest he types his question.
Possibly, maybe he should type because I'm unable to pick him. So maybe he should be able to type and I should be now in position.
But I'm back.
Okay.
So, Sai was asking on that formula of Newton-Raphson. You are getting. For us, our teacher had the xn plus 1 then equaling to xn plus 1 then minus. So I'm confused. For you, you are using x naught. I don't know why he gave us that xn plus 1 again, then minus the
how was it?
Derivative of f of x, then I don't know why.
Like you,
it was the xn plus 1
plus 1
plus 1
again plus 1
equaling
here.
to xn plus 1 then minus.
You are saying it is xn plus 1 here.
Then xn then minus.
N minus here.
Then the others were okay. The f of xn then over derivative of f of x. So I don't know.
Where is the confusion?
Am I the one who copied it?
I'm not getting
it. Plus 1.
There is a plus 1 here.
On the after the equal sign.
Okay, so it is like this. You are saying it is like this. Xn plus 1 is equal to 1. There is 1 here.
After the equal sign.
There is 1. No. I think you made a mistake there.
Why it was?
Because you are saying xn is equal to 1 minus f of xn over f derivative of xn.
Yeah.
Like this. No. This is not the expression. This is not the formula for Newton-Raphson method. I think you might have copied it wrongly because this is not how it is stated. This is how it is stated. It is xn plus 1, which is equal to xn minus f of xn, then divided by f derivative of xn. So this is not 1, but xn. Yes.
Okay.
Unless maybe there is someone who also have this one here of 1, but I doubt. Any other person who has a 1 there? Let me listen to someone here. Yes, please. Yes, Saimo.
Good evening, sir.
Yes, good evening.
Sir,
yes.
For me to remember that first part A, when I integrated that one, I have got 160.
You have got 160?
Yes.
By integrating?
I just integrated, yes.
Yeah, 160 is okay.
Okay.
Is okay. That is actually also what.
Thank you, sir.
That is also actually what we got as well.
Okay, sir.
Okay, please. I hope that is the formula that we all have. So in case you have here one, please change that one. It should be xn. Now we are given the initial estimate, that is x naught. It means that is at a point when n is 0. That is the initial value. So when n is 0, we come back to this. So it means you will have x of 1. So x of 1 will be equal to, where there is n, we are putting 0. So it will be x naught minus f of x naught divided by f derivative of x naught. That is what we shall have. So what next we need to look at is what is x naught, what is f of x naught, what is f derivative of x naught. So when we look at what we have, our x naught is 4. So it means here we shall have 4. Here we shall be having 4 here, but we need f of 4. So what will be f of 4? So f of 4 is same as substituting where there is x. Remember, our f of x is this. This is our f of x, this one here. So this is our f of x. So where there is x here, put a 4. Where there is x here, put a 4. Then when you put a 4, you'll be able to get f of 4. So this will be our f of 4. In other words, where there is x naught, we are saying that this will be x1, which is equal to x naught, that is 4, minus f of 4 divided by f derivative of 4. So we have f of x, which is this, so put 4 where there is x. We have f derivative of x, so we need f derivative of 4, so put 4 where there is x. So this will be able to give you f derivative of 4. So after getting f of 4, which is this, go on and substitute in f derivative of x. Go on and substitute in f derivative of x. The f derivative of x, we got it together here, which is this. So where there is x, put x equaling to 4. So when you do that, you should be able to get this value. So it means now you will come and substitute in this expression. So where there is f of 4, put there negative 0.32. Where there is f derivative, put there 1.44 and get the value for that. The value for this will be 4.2222. This will be the value. Another thing that I need to tell you here is that the value here, the minimum decimal places here you should use, they should be at least 4. So don't round off this and say 4.2 or 4 alone. That one will be wrong. So at least the minimum should be 4 decimal places. So we shall be able to get our x1. So you need to confirm that. Should be able to get our x1 as 4.2222. So check and confirm that. These are the values of depth, so we expect them to be in meters. That will be our x1. So having obtained the x1, you need to look at the error. You need to look at the error because they are telling us that the error should not actually be less than, because they are saying should have an error tolerance, not exceeding, meaning should not be less than 0.1. So you need to look at the error. What will be the error? This is x1. We had this as x naught. So you get the error by taking the magnitude of x1 minus x naught. So you get that. So our x1 is 4.2222. So you are subtracting x naught. X naught, we had it as 4. So take the magnitude of that. So you should be able to get as 0.2222. So but this value, you realize that this value will actually be greater than 0.2, 0.1. So this value will be 0.2222. That will be the error. And this error is greater than 0.1. This error will be greater than 0.1. But we need our error not to be exceeding, meaning our error should be less than 0.1. So looking at this, it means we cannot take x1 equaling to this to be our value, because the error obtained is still greater than 0.1. So we shall go on and look at the second iteration. We shall now use x1, which is this, and get x2. So we use x1, we use the same Newton-Raphson formula, which is this. So it means where there is now n plus 1, now our n will be 1, because this was n naught. So now we shall be looking at n equaling to 1, and that is when we are using x1. So we are using x1 as this. So go on and get f of x1. So go on and get f of x1. That is same as f of 4.2222. So substitute it in the expression where we had our f of x. Substitute it in this expression here. This expression, this one here. So substitute it there. Then you will also substitute it in the one for the derivative. So when you substitute it in that expression, you should be able to get this value. Then when you substitute it in the one for the derivative, you should be able to get the value. Then you will again refer to xn plus 1 equaling to xn minus f of xn divided by f derivative of xn. So for this case, you are looking at n equaling to 1. So you are looking at x2, where there is n, we are putting 1. So this will be x1, where there is n, we are putting 1. So this will be x2, x1 minus f of x1 over f derivative of x1. So looking at this, x1, you already have it. This is 4.222. This value is f of x1, which we have obtained here. Then f derivative is what we have obtained here. When you put them in this expression, then you should be able to get this. Now from this, again, you need to look at the error. So for this case, we shall be getting x2 minus x1. So when you get x2 minus x1, you should be able to get this, and this value is less than 0.1. So if it is less than 0.1, then we can say that the required accuracy has been achieved. So the accuracy we wanted is that the error should be less than 0.1. And for that case, it means that the pump should be installed at a distance of this from the selected river bank. Remember, that is what we needed. So they wanted that you need to determine the required position of the pump using an iterative method. And that position obtained should have an error tolerance of not exceeding 0.1 meters to allow stable installation. So basically, we shall be able to conclude that the pump should be installed at a distance of 4.265. This value here is the one that has given us the required accuracy. So that should be the required answer. So basically, that is all about our item number 1. That is all about our item number 1. This was a compulsory item, and I hope this item is very okay. And from that, then we will be looking at the next. We will be looking at the next part, and that will be our item number 2 and number 3. Rubowa, you have a question? I see your hand is up.
Thank you, sir.
Yes, please.
My question is like a concern. Somewhere where you stated the iterative formula.
Let me go back.
Now, before the formula is xn minus f function xn out of the derivative of xn.
Yes, please.
Now, my question and concern is, as if I look at the flow, shouldn't we first write function of xn? Then we say is equal to 4 minus 0.124 into xn minus 10. Basing on the substitution of the formula.
Of the formula. Like it should be. This is what you are saying. You are saying we say xn minus. So you put
instead of
yes, then you put f of xn. So you put this. Is it?
Okay, like there is f of x is equal to 4 minus 0.1.
Yes, so it means f of xn will be 4 minus 0.12 into xn minus 10, which is squared. This is our f of xn, and the f derivative of xn is negative 0.24 into xn minus 10. Yes, that one is okay. Then you substitute them here, and then you put the values. That is what that is very okay. That is very okay. Only that what we did, I simply simplified it from here. Got the f of x naught. I simplified it here just to show the procedures. But this is okay. You get your xn minus f of xn. F of xn is here. So substitute it here. Have xn plus 1 as xn minus 4 minus 0.12 into xn minus 10 which is squared. Divide this by negative 0.24 into xn minus 10.
I got you, sir.
Yes. So
Then
this one.
another,
yes, please.
another thing is about the decimal place.
Yes, yes.
That thing over, you said at least 4 decimal places. I got that one. Then the question is on, you help me and you scroll to where you got the magnitude there.
Yeah.
That magnitude, there is something I'm trying to recall from my teacher. Somewhere I said decoding to 1 decimal place. When do we decode to 1 decimal place?
1 decimal place is maybe the question specifies the number of decimal places you should have. If the required number of decimal places is 1 decimal place, then you can put it to 1. But in most cases, in errors, because here we are dealing with errors, it is always important to maintain very many number of decimal places, because you recall that the moment you do the round off, you are creating rounding off errors. So it means you are creating an error already in a number which is having an error. So it is always important that you keep maintaining very many decimal places. Maybe at the end to look at, then you look at the accuracy required. So if the accuracy required is at 1 decimal place, now you can put it to 1 decimal place. To which significant figures you can put it there. So you look at how the question is. If the question specifies the accuracy at the end, as you maintain your very many decimal places at the end, you put the answer to the required accuracy. So if the accuracy is to 1 decimal place, then you have to make sure that now you put it to 1 decimal place. If it is to 2 decimal places, put it there. But at first, at least be maintaining as many number of decimal places as possible. And actually, in mathematics, the minimum number of decimal places for numbers that have no exact values, like you can, when you divide and maybe it is not like 4.5, it is not exactly like 3.7, so long as it is having very many values, it is always important to put your answer to 4 decimal places. Maybe if at all you are looking at angles, those ones you can put it to the maximum of 2 decimal places. But any other thing, the accuracy should be to 4 decimal places.
There is something I've said of angle. If I code my angle to 1 decimal place, I'm not accurate.
That one is still okay, but the maximum should be 2. But even when you have 1, it's still okay. Yes, but the maximum should not exceed 2. That is to the angles.
Okay, now even in the other trapezium rule, I again also stick to 4 decimal place, or?
Yes, trapezium rule also stick to 4 decimal places as well.
Okay.
Yeah, but if they say that if the accuracy is to 4 decimal places, maybe in the question they are telling you to 4 decimal places. Then when you are dealing with the values, then put them to more than 4 decimal places. When you are dealing with the values, maybe let them be to 5 decimal places or 6 decimal places. But
in the table.
Yes, in the table. Then at the end, bring it to the required accuracy, which is 4 decimal places. So if they want 3 decimal places, don't deal with 3. Be dealing with more than 3.
In the table.
Yes, in the table. Then at the end, your answer should be to 3 decimal places.
That's great.
Yes, if they are specific, they specify they need your answer to 4 decimal places. Then in the table, don't deal with 4 decimal places. Deal with 5 and above. But the answer, bring it to 4 decimal places.
Okay, sir.
All right. So that is our item number 1. And from there, we now come to section B. So section B, you are required to answer only 2 items from this section, choosing 1 item from each of the parts 1 and 2. So we need to start with part 1. And the part 1, as you all know, part 1 is from statistics and the data, that is data, probability, and the statistics. So you are dealing with data analysis specifically. So things of statistics, probability, all that, we find them in part, that is part 1 of section B. Okay, so let us look at this item here. It says, James is a university engineering graduate who, due to employment challenges, took a part-time teaching job at his former high school. During a mid-term assessment, he administered a test to his senior 5 applied mathematics class. The scores obtained by 200 learners are summarized as below. So we have the marks from 10 to 20, 20 to 30, and so on. So these are the marks and the frequencies. So James wants to determine if his class performance has improved compared to the previous year when 150 out of 250 students failed to obtain the pass score of 40. Then later, seeking higher income to sustain his family, Mutima transitioned from, that should be James, because we are dealing with James here. So James transitioned from teaching to establish a commercial bakery. He acquired a packing machine to automatically seal loaves of bread. The weight of the loaves produced by his baker follows a normal distribution with a mean of 5 kilograms and a standard deviation of this. During initial trials, some loaves had either too little or too much dough, leading to packing machine errors. On the first day of production, 1.5% of the loaves were rejected for being underweight and 1% were rejected for being overweight. Now, they are telling us that we need to find out if there is an improvement in the students' grades if pass mark is fixed at 40%. And then find the acceptable weight range for the loaves of bread to ensure they are not rejected. And then see if James adjusts the automated machinery so that only 0.5% of the loaves are rejected for being overweight. Then determine the new maximum acceptable weight as threshold. So that is what we are required to find out. So they need us, one, find out if there is an improvement in the students' grades if pass mark is fixed at 40%. So we are given the marks, we are given the frequency, and we are told these are the scores by 200 learners. So these are the scores by the 200 learners. So let us first of all look at if there is an improvement in the students' grades because we are given the pass mark at 40%. Okay, so we are given the marks, we have the frequency, so what best can we use here? So any ideas on what we can use to show that there is an improvement? What do you say? Anyone who can give us an idea on what we can use to find out the whether there is improvement or not? Yes, I see Trevor, your hand is up.
Yes, sir. Making the average, we can plot an Ogive. Yeah, so after plotting the Ogive,
yes,
we are going to find on the side of geometric frequency, we shall find when if the number we are going to get, which is like above or like which are above the pass score of 40. If like we are going just to find number of students who got the pass score of 40, and you compare it to the previous one.
Okay, please, thank you. So basically, looking at that, that is what Trevor said. We shall be using an Ogive. And looking at the marks, so we already have the marks. The marks are already continuous from 10 to 20, 20 to 30. So it means our marks here will act as the class boundaries. But in case they were not, like 19, 10 to 19, 19 to 30, 19, okay, 10 to 19, 20 to 29, maybe 30 to 39, then you will first of all look at the class boundaries. But for our case, you realize that our classes are continuous. So actually what you are given here are already class boundaries because they are already continuous. So we shall not really take time in getting the boundaries. So we already have that. So to look at the improvement in performance, we shall be using the graphical method. So to look at the graphical method, we shall be looking at an Ogive. And since we already have our classes, which are already cumulative, our classes are already continuous, so these will already act as our class boundaries. Then we have the frequency. We need to get the cumulative frequency. So you begin with the first value begins, that is 18. 18, you add there this value, you get 52. 52, you add there 58, you get that next value. So you get this, add there 42, you get the next value until you come to the last value. Now after that, we shall look at the Ogive. And Ogive, we shall be basically having the upper class boundaries on our horizontal axis and the cumulative frequency on the vertical axis. So this is our Ogive, where we are having the cumulative frequency here, and then we are having the max. These are our upper class boundaries. So here we are having upper class boundary. So looking at our classes, we are starting with 20 to 30 to 40 to 50 to 60, 70, 80, and 90. So these are the classes that basically we are starting with 20, 30 up to 90. So we shall plot that. I hope everyone knows how to plot that. So 20 will be corresponding the upper class boundary here. 20 corresponds to 18. 30 corresponds to 52. 40 corresponds to 110. 50 to 152. 90 corresponds to 200. So that is what we shall be plotting. So 20, 18. So 20 corresponds to 18. So you get 18 where it is, and that is where we shall put our point. So 30 corresponds to this value here. 30 corresponds to 52. So you look for 30 here and 52 where it is, then put a what? Put a point there. So we are going to be joining this. Trevor, you have a question? I see your hand is up.
Like this 10, I'm seeing that 10 and the 20, they are in the same. So why putting the 10 on 0 and yet the 10 and 20 they have the same?
No, this is not a plotted point. I just joined from here, but that is not a plotted point. So I was just making my curve. So this is not a plotted point. The plotted point is starting from here 20 with this, then 30 with that, then 40 with that. This is not a plotted point. I was just joining the two.
Oh, so it has like you can also do it. Like, it has no issue.
Yeah, it has no impact. You are just joining your curve to have just a starting point. But this is not a plotted point. Points are these ones where we are having these points. We plot with respect to the upper class boundary. So the starting point should be here, but not to leave my curve in space here. So I just joined it to this given point.
Thank you.
Yes, please. Yes. Omema Travers, you are saying something?
I'm saying something. What I'm saying, how can you identify that a number given, for instance, that item that requires to draw a graph or to just calculate or computing something?
No, for the one that requires, per this question here, when you look at this, you need to determine, for example, this is to determine the number of students. So you are looking at the number. When you are looking at the number, you are looking at basically the frequency. And you can easily determine the number by looking at the what? By looking at the cumulative frequency, the value that corresponds to that given, because you are given the 40th square. So you need the 40th value. So if I need a mark out of which is corresponding to 40, then I must use an Ogive. But of course, a question can be set which is requiring to use a histogram, especially when they talk about the model mark. So a model mark, and then you cannot use a what? You cannot use an Ogive. You of course need to use a histogram. And if you are to draw a histogram, then it also depends your classes, especially when your class the class is having the same class limit. You also need to look at that, because you are there, you are looking at the polygon, frequency polygon. So you are looking at the frequency density against the classes. So it depends on how the question is. But for this question, you are looking for the value that is corresponding to the marker which is given, which is 40. So if I need the value corresponding to 40, the number of students corresponding to a score which is 40, and the 40 is within, for example, this class, there is no way I can easily get that number corresponding to 40 unless I draw the Ogive. So the question is valid. The question is valid to know when to use the histogram, when to use the cumulative curve, when you need to calculate, for example, the median. So depending on how the question is set, is what will be giving you what to do. The what? I'm not sure picking you well there. I think your network is a bit disturbing. I'm not picking up the words.
I was saying, with the thing of computing, I'm confused on how number is assist of computing just the statistics stuff and that of
maybe you type the question in the messages there. I can easily read and maybe go through it. It's okay. You type it. There is a provision for the chat. You can put it in the chat because I'm not picking the question well. Okay.
Yes.
Okay. You put it in the chat, then I can go through it. Okay. So, looking at this, we shall be able to plot the upper class boundaries with the corresponding cumulative frequencies to the last one. And when you join them, you should be able to get this curve here. So from this, we need to get the number of students that is basically corresponding to 40. So you realize that our 40 is here. So we need to move and get the corresponding number on this. So when you look at that, the corresponding number there will be the corresponding number will be approximately equal to 110. Because when you look at this, each of these ones here is about 5. So that is 5, 10, 15, and 20. So for this, it will also be 110. So you take the value which is here. So that will be 110. That is the number that corresponds to 40. That is the cumulative frequency at the 40. That is 110. Now, after getting 110 as the number that corresponds to a mark, which is 40, then we need to find out for the students who get these ones here from 40 and below, these ones here. So which means those are these students here from 110 and below. Those are the students who have failed. So in general, 110 students, the students who have not got the pass mark. The pass mark is 40. So all those ones who are getting below this 40, these are the students. The number is 110. But above 110, it means those ones are getting the pass above the pass mark. So here, the students below 40 are 110, meaning that the students above or equal to 40, those ones from 40 and above class, those ones here are these students. These are the students. So that is same as 200 minus 110, and those are 90 students. So the 90 students are the students who are getting more than 40 a score. So it means that the pass rate, when we look at the pass rate, because if 90 students passed here, it means the 90 students passed. 90 students, these students from here to here passed. So the 90 students passed. So it means what will be the pass rate? That will be 90 divided by the total number, which is 200. You multiply by 100, and that will give us 45%. But when you look at the previous year, they are telling us James wants to be has improved to the previous year. Previous year, 150 out of 250 students failed. So they are telling us that 150 out of 250 students failed last year. So how many passed? Those who passed are same as 250 minus 150, meaning that 100 students passed. So 100 students passed. So what is the pass rate for the previous year? If 150 failed out of 250, it means 100 passed. And if 100 passed, then what will be the pass rate? It is 100 divided by the total number, which was 250. You multiply by 100. So the pass rate is 40%. But for this year, the pass rate is 45%. So we need to see if there is an improvement. That is what the question is asking. Is there an improvement in the students' grades? If the pass mark is at 40%, so you realize that this year it is 45 pass rate, and the previous year was 40%. So clearly we can easily say that there is an improvement in performance because 45% is greater than 40%. That is one way. The second way you can do that, you can look at the failure rate. So what is the failure rate? 110 students got below 40, which means that if you are to look at compare failure rates, you can as well compare failure rates. So for this year, how many failed? 110. Out of how many? 200. Then you multiply by 100. Here you get the failure rate. And then for the previous year, 150 students failed. Out of how many? 250. Multiply by 100. Get the failure rate for the previous year. And then the failure rate for this year. So from here, we should be able to compare the two. Where do we have the higher failure rate? So of course, if this is 45, it means here the failure rate will be 55%. Will be 55%, and here the failure rate will be 60%. So you realize that the failure rate decreased. So if it decreased, it means majority passed. So there you can as well give the conclusion that there is an improvement in performance. So there will be an improvement in performance, and that is basically what they needed there. Looking at the other part, find the acceptable weight range for the loaves of bread to ensure that they are not rejected. They are telling us the weight of loaves produced by the bakery follow a normal distribution with mean of this and standard deviation of this. But some of the loaves either have too little or too much duff, leading to packing machine errors. On the first day of production, 1.5% of the loaves were rejected for being underweight, and these were rejected for being overweight. So we need to find the acceptable weight range for the loaves of bread to ensure they are not rejected. So that is what we need to look at. Now, we need to look at the acceptable weight range. We are given that the mean is this, and this is the standard deviation. So, for this case, we are given 1.5% of the loaves were rejected for being underweight. For being underweight. So, meaning we need to first of all look at what is the lower rejection limit. So that is what we need to look at. So we are told that X, we are told here that 1%, 1.5% of were rejected for being underweight. So we need to know what is the limit for underweight. So that is X less than L, that is the lower rejection limit, and this should correspond to 1.5%, which is 0.015. So you need to manipulate this. So to manipulate this, if it is less than, it means here we have a 0.5 plus the table reading of L. Okay, before that, we can even first deal with standardization of this. Before that, let us deal with standardization. That is X minus mu over rho less than L minus mu over rho, which is equal to 0.015. So this will be Z less than, this is L minus 5 divided by 0.2, which is equal to 0.015. So for this, this one here, P is less than Z. Okay, P of Z less than this one here can be easily interpreted as, this one here can be easily interpreted as, this, if it is less than, that is 0.5 plus the table reading of this, L minus 5 over 0.2, which is equal to 0.015. I hope you know that if you are having this, so this is like you're having your Z1. So you're having P of Z less than Z1. So equaling to 0.015. So if you are having your Z1 value here, Z1. So if you need the probability of Z less than this value, if probability of Z less than value is the whole of this, remember from here to there, that is 0.5. So it means you are having the whole of this, which is like you are having this as 0.5. The whole of this from here to there is 0.5. From here to there is 0.5. So it means you are having 0.5 plus the probability of 0 less than Z less than Z1. So plus this probability here, from here to here. So you are getting from here is 0.5 up to here. You are adding there the probability from here to here, which is this. So the same way we are doing that. So this here is same as taking the table reading, is same as taking the table reading of Z1. So you go to your table and directly take the table reading of 0.1, then add there a 0.5. So this is what we are doing here. So meaning that this, when I take this one on the other side, I will have the table reading of L minus 5 divided by 0.2, which is equal to 0.015 minus 0.5. So this will give us the table reading of L minus 5 over 0.2, which is equal to, someone can get for us that value.
Yeah, it is negative 0.4885.
0.485.
Yes.
Thank you. Now from here, if I'm taking the table reading of this, so it is same as having L minus 5 divided by 0.2, which is same as taking the table reading inverse when I take this one on the other side of negative 0.485. So this is actually same as minus of the table reading inverse of 0.485. So this is L minus 5 over 0.2. Now, this will be, when we talk about table reading inverse, so this is our table here. This is our table. So this is where we take the values, cumulative normal distribution, P of Z, where here you have this one here. This is what we were talking about. So the table reading, when you are looking at the table reading, inverse, table reading inverse. So you will be looking for this value in this table here within here. Okay. So we need that value, and that value is 0.485. So we must look for a number which is that one or close to that. 0.485. 0.485. We need to look at where 0.485. 0.485. This is 0.473. So we need to go on and look for 0.875. So the table reading inverse, you are looking for that value within here. 4830, 4838, okay. So we should be able to get it somewhere like here. 0.8485. Was it like that? Let me confirm. 485, okay. So 4850, this is the value. So this value corresponds with which value? 2.1. So we have 2.1. Then go upwards in this one here to take that value. So when you go upwards, it will be 7. So it will be 2.17. So that is the value which you will put here. So it means your L minus 5 over 0.2 is same as negative of 2.17. Okay. So now from here you need the L. So L minus 5 is negative 2.17 times 0.2. So your L will be, take this one on the other side, 5 minus 2.17 times 0.2. So your L will be equal to, you get that value. So which value do we get there? 5 minus 2.17 times 0.2?
4.566.
4.566. So that will be our L. 4.566. So it should be this. We should be taking this as our value. Okay. So that will be our L. That is the lower limit. Now you need to go on and get the upper limit. So the upper rejection limit. So what will be the upper rejection limit? So that is basically what we need to look at. Now, for the upper one, I hope this one is okay to everyone, because we shall be following this almost the similar method to do that. Okay, so for the upper rejection limit, they are telling us that the loaves were okay, and 1.0% were rejected for being overweight. Okay, so we need to get that upper value to which the rejection occurs. So we are saying probability of x greater than like a value u is equal to 0.01. And I hope we should be able to, this u here is the upper value. So here we shall now standardize this. So this will be probability of x minus mu like that. So that will be z greater than u minus the mean divided by the standard deviation, which is 2. 0.2, 0.2. So I hope the mean is okay. Yeah, mean is 5. Okay. So this should be equal to 0.01. So of course, this value here, it should give us, if it is greater than, that is 0.5 minus the table reading of this, u minus 5 over 0.2, which is equal to 0.01. The reason why we are doing that is if we are having this, this is 0.5 this side. So if I'm looking at this value as my Z1, so if I'm looking for the as probability of Z greater than Z1, so I'm looking at this. So if you are looking at this, it means the same as getting the whole of this is 0.5 from here up to here. So it means if the whole of it from here to here is 0.5 and I need only this part here, then it means I need to get the probability from here to here. If I know it, then I get 0.5 minus that probability. That is probability of 0 less than Z less than Z1. So when I get 0.5, the whole of from here to here, I subtract this probability from here to here, I get this probability from here up to this given point. So that is why we are using 0.5 minus the table reading of this value, which we are calling Z1, then it is equal to this. So likewise, you can take this one the other side, such that you have negative table reading of u minus 5 over 0.2 to be equal to 0.01 minus 0.5. So looking at that, you have negative table reading of u minus 5 over 0.2. You can get for us this. So when you look at that, what do we get there?
Negative 0.49.
Negative 0.49. So when you take negative on both sides, you have the table reading of u minus 5 over 0.2, which is equal to 0.49. So as we did, we shall take the table reading, and this means that the table reading of the, okay, let us take the table reading the other side. We shall remain with this table reading inverse of 0.49. So we need to get the table reading inverse of this. So we shall go back to our tables and look for 0.49. So we need to look for 0.49. 0.49. So when we look at this 0.49, so this is 4898. Okay, but the next one is 4901, which is greater than 49. So it means we shall first have 23, but this value, which value is it? We go up, is 2. The corresponding value there is 2. So 2, 3, 2. But this is 4898. So it means if we get 0.4898, we need to add there 0.2, isn't it? So we need a 2 somewhere there. So along with this word, we have a 2 here in this one. So go upwards again. Go upwards like that. That is 6. So that will be 6. So this is the value which you will put. So 2.326. 2.326. That will be the table reading inverse of this. So that is u minus 5 over 0.2. So get your u. Get your u. U minus 5 is equal to 2.326 times 0.2. And u will be equal to 5 plus 2.326 times 0.2. Get for us that value.
5.4652.
5.4652 kilograms. So that will be the upper limit. So which means when you look at what we need, the acceptable range. So what will be the acceptable range? Beyond this, there will be a refusal for being overweight. Less than this, they will be refused for being underweight. So it means the acceptable range will be the range which is from 4.566 to that is the acceptable range to 5.4652. Or you can simply have it as 4 point that at that. So that will be the acceptable range. So that will be the acceptable range, and I hope that part is okay. So you have your answer to 4 decimal places. Maintain your answer to 4 decimal places. Take your answer to 4 decimal places. And that will be the answer there. Okay. So with that, it means our part B will be done. Yes, someone has a question. Weko Saimo, you have a question?
Yes, good evening, sir.
Yes, good evening to you.
Now when you are concluding the answer, don't put the units like kilograms.
We put
what I've seen, we have just ended. Yes.
Now you will say the acceptable weight range for the loaves of bread is so. You're right, but if you write it like this is already in bracket, so you cannot include here kilograms. But when you are writing it here, you are putting kilograms, but you need to give the conclusion. So you can give the conclusion now basing on the question. So the acceptable weight, the acceptable range for the loaves of the bread is. So the range you don't put like this. You leave it like this. You either put it like this or you put it like this. That is the range. So you cannot put this one kilograms less than or equal to. So this is okay when you put it like this. It's okay. Is it fine? Yes, but when you are writing it, like after getting your U, you can maintain that. So you can simply say the acceptable weight range is from, now you can put the units. If you say the acceptable range is from 4.566 kilograms to 5.4652 kilograms. Now here you can include the kilograms if you write it in your words like that. So the acceptable range is from this to that, ensuring that the loaves are not rejected. So that should be your conclusion. Okay. So from there, we look at the last part. If James had just the automated machinery, so that only 0.5% of the loaves are rejected for being overweight, determine the new maximum acceptable weight threshold. So they are saying if James adjusts so that only 0.5% of the loaves are rejected for being overweight, determine the new maximum acceptable weight threshold. So we want to determine the maximum acceptable threshold if the machinery is adjusted such that only 0.5% of the loaves are rejected for being overweight. So we shall look at that part. So still it will be related to what we have done. So the new upper limit when rejection is only 0.5%, it means now you are having P of X greater than U. So that is the new upper limit, and this should be equal to 0.5%, 0.005. So standardize this will be Z greater than U minus 5 over 0.2, which is equal to 0.005. So from here, like the way we did, if it is greater than, that is 0.5 minus the table reading of U minus 5 over 0.2. Okay. So this should be equal to 0.05. So take this the other side. So I hope for this it should be easier for you now. So take it to the other side, get 0.05 minus 0.5. So someone to get for us that value. What do you get there?
Negative 0.495.
Negative 0.495. So take the negative on both sides and you'll be able to have that. Okay, so next we shall take the table reading inverse of that. U minus 5 over 0.2 should be equal to the table reading inverse of 0.495. So we get the table reading inverse of this. So what will be the table reading inverse? Okay, the value is 0.495. 495. 0.495. 0.495. So things should be between this and this, because this is 0.4949. This is 0.4951. Okay, so it should be between these. That is 2 point, let us see, 2 point what? 2.5. Then you go up right there. So 2.5, then we go to that, to this value here, and that will be 7. So that is the value we shall put there. So that is 2.57. Okay, so that is the value we shall have. So 2.57, 2.57. Okay, so 57. So this one here, 57. Then you need the 1. So these values are actually the same. This one 0, 0, 1, 1, 1, 1, 2. So these values are actually applicable to even these ones here. So meaning that if I need the extra 1, so extra 1, so you have, that's why there you can even take up to 6 value. But if you take this one, this is approximately equal to that. So that will be 2.57. So it means you will have u minus 5 over 0.2, which is equal to 2.57. So u will be equal to 2.57 times 0.2 plus 5. So what will be u?
5.514.
5.514. So kilograms. So take to 4 decimal places. Only this? Or there are other decimal places?
Only that.
Only that. So that should be the value for the new upper limit when rejection is 0.5%. So should be able to get that, and that should be the answer. So looking at what we needed, so it means the new maximum acceptable weight threshold is that. So the new maximum acceptable weight threshold is 5.514 kilograms. Yes, Bruce.
Sir, I would like that after I have not understood how we are getting values from the table.
From this table?
Yes, from the table.
We have table reading values and the inverse values. When you are looking for the inverse, like when I say inverse of this, inverse of 0.45, okay?
Yes.
So you need to look for this one within this one here, in this table here. So you need to look, yes, within here, these values here, which are already here. These are the inverse values. So like you need to look at where do I get 0.45. So you go through this. You are looking at where you are getting 0.45. So you check, where can I get 0.45? Around there. When you look at this value, this is this one represents 0.4495. But the next value is 0.4505. So this, it means my 0.45 lies between these two, isn't it?
Yes.
But of course, this is above that value. So I will first take this value. So this value is 1.6. See? So you first write 1.6. See? Then I come up to here. This value here, I need to go and get a corresponding number up, which is 4. So this is the 4 I will add here. But now I need 0.45. But the value I have is 0.4495. Now on top of this, I need to add the value, which is 0.0, because this one goes to 4 decimal places. These ones here are the ones you add there. So these ones are like 0.00004 zeros. So they are written like 0.0000. Okay. Then, so it means I need to add there like a 5, 0.00005, such that when I add it on this, it will give me 0.45. So you go here, it means you will have added there this value on top of this to get 0.45. So if you had 1.6 So the Z value you will be using here will be 1.64. Then the value corresponding to this go up and pick this value, which is 5. So you will put a 5 here, meaning the table reading. If, for example, now I ask you what is the table reading of 1.645, okay, then you should be able to give me this. And if I ask you this, you should be able to give me this. So this is the inverse. But when we are reading this, you can look at the table reading of like 0, the table reading of like 0 point maybe 45, maybe 0.45. So where do you get that? You come here when you are taking table reading. This is not the inverse, is now the table reading. So you come here 0.4. If I'm taking the reading of 0.4, so 0.45. So I first look for 0.4 here. So this is 0.4. Then 5. This is 0, 1, 2, 3, 4, 5 is here. So it means 0.45 is this value. So it means the table reading of 0.45 is the value which is 0.1736. Okay? But now, if I ask you what is the table reading inverse of 0.1736, then you should be able to go back and look for this one here directly in these numbers here. And of course, you will find it here. So when it is here, the table reading inverse of this will be here. But which value corresponds to that? It is 0.4 and 5. So you write 0.4 and 5. So taking the readings for this, you are either taking the table reading, probability of Z directly, that is the table reading we are talking about. Then the inverse are obtained from here. But the probability of Z, like you are taking probability of 0 less than Z less than 0.45, you are taking these values directly from here. 0.4, then where is there is 5 is here. The value which is coinciding between 0.4 and 5 is this, and this is the value that you take. So that is basically what we follow. So depending on how the question is, then you should be able to do it. Yes, Bruce. So for different depending on how the question is set, you should be able to get the answer. So when you are looking at the table reading, you are taking the probability of Z direct. Then the inverse, you are getting the values. You are looking for those specific values within these values that we are having here. So in most cases, the easier ones are taking the table reading because you take them directly. You look for the value where it is, get the corresponding value, and that is done. So that is what is done there. Okay, so that is about item 2. And we have about 30 minutes to complete this. So I want us to rush into item number 3 very fast. So we can at least have 3 items solved, and we shall be remaining with only 2 items. So we can go through item number 3 first. So they are saying in 2024, the Auditor General released a report indicating that the several new constructed major roads in Uganda failed to meet minimum quality standards, deteriorating rapidly before their projected lifespan. Now, we are given that in response, the Ministry of Works.
The screen is off.
The screen is off?
Yes.
Yeah, let me check. Is it back?
Yes.
Okay. So we were having that in response, the Ministry of Works and Transport initiated a strict quality assessment framework. During the rehabilitation of the Matuga-Kasangati Road, civil engineers collected soil samples at different depths to analyze the relationship between the soil depth and its sand composition. The percentage of sand Y at various soil depth X in centimeters was recorded as follows. So we have x and y values. Now, simultaneously, the ministry contracted an engineering firm to audit the quality of steel bolts used in bridge construction. The firm's quality assurance supervisor monitors a metal workshop where these bolts are manufactured each day. The supervisor randomly samples 50 bolts and records the number of defective bolts x, where 15 is less or equal to x less or equal to 20. From historical inspection records, the supervisor identified a clear pattern in the daily defects. For x equaling to this, the probability of getting x defective bolts is proportional to x minus 12. For x equaling to 18 and 20, the probability is proportional to 25 minus x. The workshop records show that the probability of the number of defective bolts exceeding 18 is 11 over 54. The plant manager wishes to determine whether to recruit more inspectors or replace the manufacturing machines based on the following operational criteria. The first one, recruitment policy. If the expected number of defective bolts exceeds 18.5, more inspectors must be recruited. Replacement policy. If the probability of getting between 16 and 18 defective bolts inclusive exceeds 0.4 and the variance of the defects exceeds square root of 5, then the manufacturing machine must be replaced. There is someone called Pud. Please try to mute there. Okay. So they're saying if the probability of getting between 16 and 19 defective bolts inclusive exceeds 0.4 and the variance of the defects exceeds square root of 5, then the manufacturing machine must be replaced. So our first task is to comment on the relationship between the depth of the soil and the percentage of the sand in the soil. So we are on item number 3, or we have already read through the item. So our tasks, we need to comment on the relationship between the depth of the soil and the percentage of the sand in the soil. B, we need to advise the company whether 1, to recruit more inspectors, 2, to replace the machines. So we need to look at that task there. So first of all, we are given this table here of x and y. So for this table, we need to get the relationship according to what we need here. We need to comment on the relationship between the depth of the soil and the percentage of the sand in the soil. That is what we need. So let us look at the relationship between the depth of the soil and the percentage of the sand in the soil. So before I talk about that, what can we do to create the relationship between x and y? Can someone tell us what basically we need to do?
So if you are given such data, we are going to use the correlation, whereby we are going to get the number, these values, either ascending or descending.
Yes. Okay, thank you. So basically, we shall look at correlation. So we need to look at the relationship between x and y, and we shall be using the correlation. So to look at that, we shall test the relationship between x and y by using the Spearman's rank correlation. That is what we need to use. So we are having X, we are having Y values. So we need to rank them. Like he has said, either you can use the ascending order or you can use the descending order. So if we follow we rank starting from we can start from the smallest to the biggest. So if we start from the smallest, so for the values of X, the smallest is 20. So we give this one 1. The next value is 25. This one becomes 2. The next value is 35. This one becomes 3. The next value 45, 4. Then 51. Okay, let us see. This is 4. This is 51. What else? This is 50. Okay, yeah, 4. This will be 5. Then this will become 6. This one will be 6. This one will be 6. Then what else? This is 60. This will be 7. Then this is 65. This will be 8. 75. This will be 9. And lastly, this will be 10. That will be 10. So that is the rank of, that is how we can rank X. Then next we shall start with, again, in here, the smallest again. So in here, the smallest in these values of Y is this. That is 1. So the next one after that, this one is 2. Then the next one, this is 68. 70 will be 3. Then the next one, 77 will be 4. 79 will be 5. What next? 79. Then this is 84 will be 6. 86 here. 86 here. So we were on which one? We were on 6. So this will be 7. And this one will be 8. So they are the same. So it means this will be 7 plus 8 divided by 2. So we shall get 7.5, 7.5. So we shall go to the next value. That will be the 9th value. That is 92. Okay, 92. That will be the 9th value. And lastly, we shall have 96. That is the 10th value. So we have followed from smallest to the biggest. So that is ascending. If you want, you can follow descending, where you are beginning with the biggest to the smallest. But if you do that for X, do the same for Y. So don't do smallest to the biggest for X, then biggest to the smallest for Y. That will give you something different. Now, from there, we shall get the deviation, and that will be R of X minus R of Y. So here it has no problem. So long you can easily get even R of Y and R of X, because what we are interested in is D squared. So get this minus this. So you should be able to get these values. Then you get D squared, which will be able to give you these values here. So you are squaring this to get these values. So from here, get the summation of D squared, which will be 321.5. So from there, we shall use the Spearman's rank correlation, and we shall be having 10 of our items. So this is 1, 2, 3. These are pairs. So there are 10 pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our n will be 10. So summation of D squared, we have it here. N is 10. So that will be 10 into 10 squared minus 1. Subtract, simplify everything, and you should be able to get your that value there as that value should be approximately equal to 0.9485. 0.9485. So after that, you should be able to give, this is a minus, should be able to give now, if your value for rank correlation is this, then you should be able to give your conclusion. So basing on what we have, we shall be saying that there is a very strong correlation, but that correlation is negative. So there is a very strong negative correlation between soil depth and percentage of the sand. So if they ask you about the significances at different percentages, that is at 5% and 1%. So now, like for this one, we have got, if they were to talk about the significance maybe at 1% or 5%, then you need to come to your table and look at the value. If your value exceeds if that value here, if magnitude of this, so for example, the magnitude of this is 0.95. So if you are looking at if the magnitude that is 0.95 for how many pairs? There are 10 pairs, exceeds 1 at 5%. So if you are talking about at 5% or at 1%, then you look at the number of pairs, then you look at the significance at that given what? At that given percentage. So this is at 5%, this is at 0.79, that is 0.79. That is, if that value is, you are looking at that value at 5%, you look at the number of pairs you are having, get the corresponding value. Then at 1%, get the corresponding value. But of course, you do that depending on the question. They can specify that you get a significance value at 5% or at 1%. So, but for this, that is not necessarily there. So we are saying there is a very strong negative correlation between soil depth and percentage of sand. This shows that as soil depth increases, that is y, as y increases, because you realize when y is like 96, x is 20. So as the soil depth increases, the sand content decreases sharply. So the relationship is strong and consistent, showing a clear downward trend. So therefore, deeper soil layers contain less sand. So we needed to comment on the relationship between the depth of the soil and the percentage of the sand in the soil. And that will be the conclusion. So as the soil depth increases, sand content decreases sharply, and the relationship is strong and consistent because it is showing a clear downward trend, and therefore deeper soil layers contain less sand. Part B, we need to advise the company whether to recruit more inspectors or replace the machines. Now, here they are telling us, they have given us this information. Where generally we are told that for historical inspection records, the supervisor identified a clear pattern in the daily defects. For x equaling to this, the probability of getting x defective bolts is proportional to that. For x equaling to that, the probability is proportional to that. And we are given some information here, but we are given these policies. One, if the expected number of defective balls exceed this, more inspectors must be recruited. So we need to look at what is the expected value. Does the expected value exceed this? If it does, more inspectors should be recruited. Then replacement policy. If the probability of getting between 16 and 19 defective bolts, of course, or the 16 and 19 inclusive exceeds this, and the variance of the defects exceeds this, then the manufacturing machine must be replaced. So these are the conditions they have given us. So we need to talk about the expectation, we need to talk about the variance, we need to talk about the probability, which is between 16 and 19. So basing on this, we should be able to give the recommendation. That is what we need to do. So now they are telling us that monitors, they are telling us that the firm's quality assurance supervisor monitors a metal workshop where these bolts are manufactured. Each day, the supervisor randomly samples 50 bolts and records the number of defective bolts. And this number is from 15 to 20. And for X values from 15 to 17, the probability of getting X defective bolts is proportional to this. Then for X equaling to 18, 19, and 20, the probability is proportional to this. So that is what we need to look at. So let us see how best we can advise the company. So we are letting the random variable X to denote the number of defective bolts sampled per day. What does this mean? It means the probability distribution will be defined as P of X equaling to X, that is equal to A into. So we are told that the probability, the first thing is proportional to X minus 12. Then the next one is the same probability will be proportional to 25 minus X. So that is the information we are told here. The probability of getting X defective is proportional to this. Here, the probability is proportional to this. So for that case, when you are moving the sign of proportionality, you must recall that specifically you need to introduce a constant. So that's why we have probability of X equaling to X. So introduce the constant here, like A, then you have A into x minus 12. Then here another constant like B, which is 25 minus x. So this is why we have these two. And this will be true for x equaling to 15, 16, and 17. This will be true for x equaling to 18, 19, and 20. So from here, since we have two different proportional relationships, then we use two constants of proportionality, A and B. So that is the reason for using A and B, because we have two different proportional relationships. Now, from what we are given, we also have this information that the workshop records show that the probability of the number of defective bolts exceeding 18 is this, is 11 over 54. 11 over 54. So we need to look at that. So let us see how best we can obtain first are the constants A and B. So it is better you draw a table, so you can easily draw the table. You have such that you have your x equaling to x and p of x equaling to x. So for x equaling to x, you are having x equaling to 15, to 16, to 17, 18, 19, and 20. So what will be p of x equaling to x? So when you put here 15, you get 3a. So this will be 3a. Put 16 here, 4a. And then this will be 4a. Yes, 4a. And this will be 5. 15. Okay, this will be 3a. Put 16. This will be 4a. Put 17. This will be 5a. Then next put 18 here. B 25 minus 18, that will be 7. So you have 7b. Put 19, 6b. Put 20, 5b. So this is basically what you will have. But again, we are given information that the probability of number of defective bolts exceeding 18 is 11 over 54. So you are told that the probability of x greater than 18 is 11 over 54. But x greater than 18, you have 19 and 20, meaning that P of 19 plus P of 20 will give you this. But P19 is 6b, P20 is 5b. So this is what we shall have. So in general, you will have 11b is equal to 11 over 54, and you'll be able to get the value of b. Then after getting the value of b, we know that the sum of these probabilities here must be able to give us 1. In other words, when you get 3a, the summation, what we are saying is the summation for all x, p of x, when you add up these probabilities, you should be able to get 1. So in other words, when you get 3a plus 4a plus 5a plus 7b plus 6b plus 5b, you should be able to get 1. So that is what we shall do here. But since we already know b, so we can have this as 12a plus this is 13, that will be 18b equaling to 1. So you already have b as that. So substitute your b there and get the value of a. So the value of a will be 1 over 18. So you will put 1 over 18 where there is a. You will put 1 over 54 where there is b. And now you'll be able to get your p of x equaling to x. So your p of x equaling to x will now be equal to that. So for the probability distribution, x and p of x equaling to x, you'll be able to get that. So after getting this, now you can look at how best you can, one, advise the company whether to recruit more inspectors. So to recruit more inspectors, the expected number of defective bolts must be exceeding this. So let us look at that. So we need expectation. So recruitment policy, the company recruits more inspectors if the expectation is greater than 18.5. So we need to get the expectation. So how do you get expectation? It is a summation of all x times p of x. So you have x, you have p of x. So you are getting this times this. So this times this, this times this, you are adding these ones here. So you have 15 times 1 over 6, 16 times this. So that is basically what we are doing. Okay, so expectation of x times the probability of x. So look at that. What is 15 times 1 over 6 plus 16 times 2 over 9 plus 17 times that? So multiply the all of these and get the expectation. So your expectation should be equal to that, and this value is less than 18.5. So if the value is less than 18.5, so it means the recruitment criterion will not be satisfied. So it means, by conclusion, you will be saying that there is no need to recruit more inspectors. Remember, more inspectors are only recruited if the expectation is greater than 18.5. But since the value we shall obtain will be less than that, then we shall give a conclusion that there is no need to recruit more inspectors. Then the next one in a very few minutes remaining, we need to look at advise the company whether to replace the machines. So what are the machines? So the machines can be replaced only when the probability between 16 and 19 are defective bolts. Probability of getting these bolts between 16 and 19 when 19 and 16 are included is exceeds 0.4, and also the variance exceeds square root of 2. So we need to get this probability and the variance of x. Then after getting that, if all these conditions are satisfied, then we shall do what? We shall give the conclusion. If not, then it means we shall also be able to advise the company otherwise. So you know how to get the probability between 16 to 19, where we have 16 and 19 inclusive. So that is probability of 16 less or equal to x less or equal to 19. And the machines will be replaced if this is true and this is true. So let us first get the probability between 16 and 19. So probability between 16 and 19 inclusive will be this. Start with 16, add their probability of 17, probability of 18, probability of 19. And add the two, because you already have these ones here. You already have these probabilities here. So get probability of x equaling to 16, 17, 18, 19, add them, and get that answer. So you should be able to confirm that it will be 20 over 27. And that value, you get this value, put this one here to 4 decimal places. So if you are to get this one, put it to 4 decimal places. But if you leave it as 20 over that, but it should be to 4 decimal places, since you want to compare it with as 0.4. So get that value, and that should be the probability. Now, after getting that probability there, maybe before we leave that, can someone get for us the value of 20 divided by 27? 20 divided by 27. Want us to put it to 4 decimal places? Yes.
0.7.
0.7.
407.
407. Okay. So it means that it should be the probability to 4 decimal places, 0.7407, and that value is greater than 0.4. So since it is greater than 0.4, the first condition will be satisfied. Now, the first condition is that the probability from 16 to 19 should be greater than 0.4. The next condition is that the variance should be greater than the square root of 5. Now you need to get the variance. So I hope you know how to get the variance. So for variance, you need to get expectation of x squared first, because variance of x is expectation of x squared minus expectation of x, and this is also squared. So you can easily get expectation of x squared, that is summation of x squared p of x. That is expectation of x squared. So you have all this. Actually, you can do all this just in a simple table, because in your table you have x, you have p of x. So you will construct another table where you will also have x, p of x equaling to x. Then you also have x squared somewhere there. Then you will also put x squared p of x equaling to x. So when you construct such a table, it becomes easier for you. So get that, because you already have x, you have p of x equaling to x, so you can get x squared, you can get x p of x, you can get x squared p of x. So you can get all these. Then after, you take the sum of x squared p of x equaling to x. So you can do that just within a table. It becomes easier. But again, you should be able to confirm that expectation of x squared. You should be able to confirm that that value is 7933 divided by 27. So when you substitute it in this expression, in this one here, because you already have expectation of x, then you should be able to get a variance as this. So get for me the variance to 4 decimal places. 1670 divided by 729
is 2.29
2.29
08.
08. So that would be the variance. Then square root of 5. So this is approximately equal to that. This will be approximately 2.23 61. So that is what we shall have. So clearly you can easily see that this value is also greater than this. So you can easily see that the variance of x is actually greater than square root of 5. So this condition is also satisfied. So clearly you realize that both conditions are satisfied, because you can easily see that this is greater than the given value, variance is greater than the given value. And they said that when all these are satisfied, if the probability of getting this exceeds this and the variance exceeds, then the manufacturing machine must be replaced. So it means we shall give the conclusion that the manufacturing machine should be replaced since both conditions have been satisfied. So that is basically what we shall be able to conclude with.
Yes.
Okay. So for those that were here yesterday, we were looking at the responses for this paper. We already looked at the 3 items, that is from section A, section B, part 1. So we have already looked at those items. So basically these are the items that we looked at in our previous session. That was section A, where we had our item number 1. We have already gone through this item. We looked at item number 2. So this was the item number 2. We looked at item number 3. So this was basically the item number 3. And today, I want us to look at the remaining items so that we get this paper done. So we want to come to part 2. And part 2, that is the part for mechanics. So that is the part where we expect to be looking at the construct, which we call a mechanics. So when we are to look at part 2, we shall be looking at 2 items, that is item 4 and item number 5. So I hope we are all ready so we can get started, because I want us to get done at least within about less than 2 hours, so we can get done with that. So here is our item number 4. Item number 4 says, due to unstable security conditions along a border region, the Ministry of Defense has established a joint command center to manage both airspace, defense, and humanitarian logistics. During an active defensive patrol, radar systems tracked 2 aircraft. To the pilot of reconnaissance, a bomber aircraft flying with a true velocity, which is given as this, encroaching unidentified fighter aircraft appears to have a relative velocity of this kilometers per hour. The air defense coordinator must establish the true velocity of this unidentified fighter to determine if it possesses an immediate threat to the sector. Simultaneously, the Civil Operations Wing of the Command Center is executing a relief drop to assist displaced families isolated by the conflict. A heavy cargo aircraft is flying horizontally at a constant speed of 70 meters per second at a steady altitude of 180 meters above flat plane. The crew must release a parachute-free container of emergency medical supplies so that it lands precisely at a designated ground collection point marked by ground teams. So the task is we need to find the true velocity of the fighter aircraft and B, at what horizontal distance from this point must the aircraft release them. So that is basically the information that we are having. Now, from this given scenario, we need to look at one, the true velocity of the aircraft, and that should give us what we need to begin with. So our task is in two parts, so we shall be answering one part at a go. So looking at part one, we need to first of all look at how best we can obtain the true velocity of the fighter aircraft. So when you look at the information that we are given, we are told that during an active defensive patrol, radar systems track two aircraft. To the pilot of reconnaissance bomber aircraft flying with a true velocity. So this is the velocity of the reconnaissance bomber aircraft. This is the true velocity. Then an encroaching unidentified fighter aircraft. So the fighter aircraft appears to have a relative velocity of this. It appears to have a relative velocity of this one here. So when they say it appears, it means that is not its true velocity. So that is that the relative velocity of the fighter in regards to the bomber aircraft. So that is the information that we are given. So you are given the relative velocity of the fighter relative to the bomber. You are given the true velocity or the velocity of the bomber. So from that, then you should be able to easily come up with the true velocity of the aircraft of the fighter aircraft. So let us see how best we can respond to that. Now, from the information that we are given, we shall let v, that is the velocity, the true velocity of the bomber, reconnaissance bomber, to be v of b, and the v of f to be the velocity of the fighter aircraft. So this one here is the velocity of the fighter relative to the bomber. Sometimes we write that one there as fighter relative to the bomber. So whichever way you write that, but this is a vector, so we shall always put that notation there for the vector. So we are having this representing the velocity of the fighter relative to the bomber, and we were given the velocity of the reconnaissance bomber, and that is v of b. So v of b was given, which was this, and the fighter appears to the bomber to have a velocity of this. So this is the relative velocity of the fighter to the what? To the bomber. So the relative velocity of the fighter to the bomber is given by this. So for those that have studied dynamics 2, you should be able to tell us what is this one equaling to. What is the relative velocity of the fighter relative to the bomber given by, in terms of f, v of b and v of f. How do we write this? Yes.
So if you are going to formulate that,
yes,
we put that v of f then minus v of b.
So we say v of f minus v of b. Okay, thank you. So that is how we write that. So we are basically interested in the true velocity of the fighter. So that is v of f. But you have this, you have this. So here we shall basically use the vector method. So here we shall use the vector method. You know how when we are dealing with this part here, you have two options, either to use the geometrical method or to use the vector method. However, for this case, you will have to use what we call the vector method, because it is easier. Already they have given you this in terms of vectors, so it is now easier to use the vector method than going for the geometrical method. So for this, you simply use the vector method. It becomes easier because it is a matter of substituting. So this one here, we need v of f. So v of f will actually be same as bringing this one the other side. It becomes v of b then plus v, that is the velocity, the relative velocity of f to b plus this one here, v of b. So you did this, you have this, and this one here is given as 150, this is 440, so you are adding there negative 150 minus 200. So you should be able to simplify that and be in position to get this plus that will be 0. This plus this will give us 240. So this will be the velocity of f, so kilometers per hour. So that will be what we call the velocity. But now we are interested in the true velocity of the aircraft. So after getting this, we can go on and get the magnitude of that. So when you reach here, you can go on and get the magnitude of that. So from here, this will be the velocity, and the velocity is given by 0 and 240. When you are to represent that 0 and 240, it means this will be in the northern direction. It will be like that. So this is where we shall have v of f. So v of f will be equaling to, so you can get this one here. That is the square root of 0 squared, the magnitude of this, plus 240 squared. So of course, which will give you 240 kilometers per hour. So that will be, this will be the velocity, and this will be the speed. So the speed is the magnitude of that. So it means we can generally say that the true velocity of the aircraft will be this, and its speed will actually be the magnitude. When you take the magnitude of the velocity, you get the speed. And if this becomes the speed, then you must also state the direction in which it is traveling. So we can easily see it is traveling due north. So we shall be able to say that the fighter is traveling due north at 240 kilometers per hour. So that becomes, this becomes the speed at which the fighter is traveling, and this becomes the direction, and this will be, see, a velocity. So that will give us part A. So part A will be answered, and part B, at what horizontal distance from this point must the aircraft release them? So in part B, they are telling us that the air defense coordinator must establish the true velocity of his INID. Okay, so that one is done, the true velocity. So simultaneously, the civil operations wing of the command center is executing relief drop to assist displaced families isolated by the conflict. A heavy cargo aircraft is flying horizontally at a constant speed of this. So it is traveling horizontally at this speed and at an altitude of 180 meters above the flat plane. So the crew must release a parachute, a free container of emergency medical supplies, so that it lands precisely at a designated ground collection point marked by ground teams. So we need a horizontal distance from this point that the aircraft must release this container. That is what we are interested in. So we shall look at the required response there. So what will be the required response? So for part B, we are basically looking at horizontal distance before releasing the medical supplies. So we are saying that the container is released from a height of 180, and it is moving horizontally at this speed. So when we are to represent that, then this will be our diagram for the representation. So this is the altitude, that is the height from which they were released, and this one here is the horizontal speed. So the horizontal speed is 70 meters per second, and for that case, it means the initial velocity vertically, that is the vertical component, will be equal to 0, since we are dealing with the horizontal component. So the horizontal component will be 70 meters per second, and the initial vertical component will be 0. So that's why we are saying actually the horizontal speed is 70 meters per second, because when you take the square root of u of x plus u of x squared plus u of y squared under the square root, then this should be able to give you the speed. So the speed will now remain as 70, since this one will be 0. So the v of x, of course, that is the u of x. U of x will be 70 meters per second. U of y will be equal to 0. So we are interested in getting this from here up to this given point. We need from here up to this given point. So let us see how best we can get that. So our first step, what we shall do is we shall determine at the time of fall. So the time taken for the body to move, to be released up to when it will be falling at this given point. So for that case, when you consider the vertical motion, because this one will be released and it will be taking that vertical path. So when we consider the vertical motion, then we shall be able to consider that S is equal to, we are referring to this, S is equal to UT plus a half AT squared. But this is in air, so that's why we shall be considering for the vertical case. So we shall consider u of y t, then plus a half a g a t squared. So here u of t we have seen is 0, so it means our height we have seen that is 180. Here we have different ways of how you can write this. Some you might include the minus, looking at your height, because it is above the ground. You might include the minus, the g, negative g. So depending on how you are taking your g, then this one will also change. So it means if I'm considering my motion to be against gravity and I introduce negative, then if I introduce the negative and I say u of y of t minus a half a gt squared, and then this one here, when I'm substituting for s, I should substitute for negative 180. And then others will remain the same. You will get the same answer. Somehow it depends on how you are taking your g value. So either your motion is against the g or your motion is not against the g. So with that, you will be able to have the same answer as someone who will be taking it as a positive value. So we are saying that u of y is 0, and for that case, we already have s as 180, so substitute. So this will be 180 is equal to, this will be 0 plus a half a g 9.8, then t squared. So we are interested in t, simplify this. So that is 180 equaling to 4, that is 4.9 t squared. So divide by 4.9, divide by 4.9. So get your t squared as 180 over 4.9. So from there, simplify and get the value for t. So if you simplify and get the value for t, then your t should be equal to 6.06. Then having obtained the t, that is the time taken, for the container to move up to this given point. So if we know the time taken for the container to move up to this given point, then we can easily get x, because x we can see that is the horizontal distance. And how do we get that? Like the way we have done for vertical motion, now we shall consider the horizontal motion. Now we are saying to determine the horizontal distance traveled, what we shall do is we shall still be using that same expression of s is equal to ut plus a half at squared. But for this case, the acceleration, the horizontal acceleration is 0. So that is, the g will be 0, where this one is g. So the g will be 0. So for that case, it means we are remaining with s equaling to u. So this is s in the horizontal, u in the horizontal, t, and then g will be 0. So this part will be 0. So if this one here is x, so we have our x as ux of t. So what is the component of u in the horizontal direction? We had that one as 70. So x will be 70 times the time taken, that is 6.06 s. So 06, okay. So this is distance, so it will be meters. So our x should be 424.2 meters. So that will be the value of x. So therefore, the surprise must be released when the aircraft is approximately 4.24 times 10 to the power 2 meters from the target. So what we wanted is at what horizontal distance from this point must the aircraft release them. So we are saying the surprise must be released when the aircraft is 4.24 times 10 to the power 2, or else you can say is when the aircraft is 424.2 meters from the target. So with that, it means our item number 4 will actually be completed. Yes, Bruce.
Sir, I would like to request whether here, because me I have got 424, then 264, and is it necessary to round off or to truncate?
Where? At time, for the time?
No. The horizontal distance.
Horizontal distance. You are getting?
Me, I have got 424.264.
Okay, let me see. You have 70 times 6.06. What do you get?
Yes. Then you multiply.
Yes, multiply.
70 times 6.06. But I when I multiply that,
yes,
I get 424.2.
0.2.
Yes. But then from the upper step, upper steps.
From here.
Yes.
So
if you get 180.
Yes, when you get 180 divided by 4.9, what do you get?
I get is 36.73469.
You
then
get 36.
When I square root.
Okay, 36
yes.
point?
73.
73.
Yes, 469. Stop from there.
469.
Yes.
Okay.
Then when I square root that answer.
When you take square root of this.
I am getting 6.0609.
09.
Yes.
Okay.
Then
okay. So when you come and place it here.
When I place it there.
609.
Yes.
Yes.
Then I multiply there by 70.
Yes.
It's when I get the 424.26.
424.26.
4. Yes. So I don't know which answer is more accurate.
This one is more accurate. Because you have to, when you consider more decimal places, it gives you high accuracy. So you maintain that. You maintain this. This is okay.
Oh.
Yes, this is okay. So if for you at this given point, you consider the 4 DPs, and then you maintain that up to the end, that is still very okay.
Oh, thank you.
Okay. All right. So let us look at our next item, and that is item number 5. So item 5 says, Mr. Rusoke plans to take his family on a vacation in December using their holiday caravan. However, before setting off, the caravan requires specialized mechanical repairs. They are saying he contacted a local vehicle recovery. He contacted a local vehicle recovery service in Mukono to tow the caravan from his residence to the repair garage. The recovery team arrived with a breakdown truck of mass 1,200 kilograms. The caravan has a mass equivalent to 2/3 the mass of the breakdown truck. The engine of the breakdown truck exerts a constant forward driving force of 3,000 newtons. During the towing process, both the breakdown truck and the caravan experience resistive forces due to the roughness of the road surface, which is characterized by a coefficient of kinetic friction. The coupling tow bar connecting the breakdown truck to the caravan is designed with a safety threshold and will snap if the tension force exceeds this. Shortly after they depart, Mr. Rusoke sets off from his home in his private car to follow the recovery team to the garage. From a stationary start, he accelerates at a constant rate of this for 10 seconds. He maintains the maximum speed attained for the next 5 seconds and then applies his brakes to decelerate uniformly to a stop at the garage entrance in a time of 2 seconds. You need to take your acceleration due to gravity as 9.8 meters per second squared. So our task is part A, to calculate part 1, the acceleration of the towed system and the tension in the tow bar. We need to use the findings to determine whether the tow bar will safely manage the trip without snapping. And part B, we need to sketch a velocity time graph representing Mr. Rusoke's journey. Using the graph, we need to calculate the total distance from Mr. Rusoke's home to the repair garage. So that is basically the information that we are given. So for part one, they are telling us that we need to calculate the acceleration of the towed system and also the tension in the tow bar. So let us look at that information which will help us to answer that. So basically, the information that will help us to answer that part will be this. So that is the first part. So they are telling us that the recovery team arrived with a breakdown truck. The truck has a mass of this. This is the mass of the truck. The caravan has a mass equivalent to 2/3 the mass of the breakdown truck. So that is the mass of the caravan. So it means since we know the mass of the breakdown truck, we can easily get the mass of the breakdown we can easily get the mass of, they are saying the required value arrived with a breakdown of this. The caravan has a mass, so we shall get the mass of the caravan using the mass of the breakdown. They are telling us that the engine of the breakdown truck exerts a constant forward driving force. So we have the driving force as that. And during the towing process, both the breakdown truck and the caravan experience resistive forces due to the roughness of the road surface. And that is characterized by coefficient of kinetic friction, which is equal to that. And they are telling us that the coupling tow bar connecting the breakdown truck to the caravan is designed with a safety threshold and will snap if the tension force exceeds this. So that is what we shall be using. So this is the information that we are given, and this information will be helping us to look at the acceleration of the towed system and the tension in the tow bar. So let us look at the required response. So basically, this is how we can easily summarize that. We are having the caravan. We are having the breakdown. So we are having the breakdown and the caravan. So what will be the breakdown? The breakdown is mass. The breakdown is mass is given. And that mass was given as, when we look at what we have, as 1,200 kilograms. That is the mass of the breakdown. So the breakdown is pulling the caravan. So as the breakdown is pulling the caravan, we are also told that the caravan's mass is equal to 2/3 the mass of the breakdown. So which means if the breakdown is of mass, so the mass of the breakdown is 1,200 kilograms. And the mass of the caravan is 2/3 of a mass of B. So which means this is 2/3 of 1,200. And this will give us 4. So that will be 800 kilograms. So this will be the mass of the caravan. So if this is our road, this road here has got what we call, it is very rough. So we expect to have what we call the frictional force. So we shall be having, since the two are moving, so we shall be having the frictional force that will be experienced by the breakdown and the frictional force that will be experienced by the caravan. So that's why we have this F2, we have this F1. And we are as well given the driving force, which is 3,000 newtons. So we have the driving force, which is 3,000 newtons. So this is the motion of the breakdown truck and the caravan. Now looking at what basically we have here, we need to find the acceleration of the towed system. So I want to find that by looking at this one here as one system. That is the caravan and the breakdown. So I want to combine the two, such as since they are all moving, because the breakdown is actually pulling this. So it means they are all moving at the same acceleration. So I want to look at the towed system. That is basically looking at the breakdown and the caravan all together. So when we have the mass of the breakdown, which is already there, the mass of the caravan we have got, then what will be the total mass of the whole system? So the total mass of the whole system will be same as getting the mass for the caravan. You add there the mass for the breakdown. So when you add these two, you will get the total mass of the system. So it means the total mass will be equal to that. Basically, because this is on the road, we expect to have the weight of the caravan as 800 grams, 800 G. This G is acceleration due to gravity, because this is already in kilograms, not 800 grams. So this is 800 times acceleration due to gravity, and that will be our R2. Then the weight will be corresponding to the reaction, that is R1, and R1 will be 1,200 times acceleration due to gravity. Now, we have got the total mass of the whole system, that is M1 plus M2. Then after getting that, we are given the total driving force, that is the driving force, which is 3,000 newtons. Now, we need to look at the frictional force. What is F1 and what is F2? Because these are the two forces that are against the driving force. So that is F1 and F2. So it means we need to get F1. F1 is mu R1, and we know mu that was given in our scenario, that is 0.12. So we are given mu as 0.12. So get F1 go on and get F2. So F1 is same as mu R1, and R1 that is M1G, that is equal to the weight of the breakdown. So when you do that, you should be able to get this. Confirm for me in case there are other decimal places. So we maintain all the decimal places. So get for me 0.12 times 1200 times 9.8. Shall we get the same answer? So as we said yesterday, all the answers should be, if you want to round off, please make sure you always put it to 4 decimal places. If it is to 1 decimal place, 2 decimal places, that is okay. But for those that you need to round off, make sure it is to 4 decimal places. Yes, what is that, F1? Is it like that?
Yes, it is like that.
Okay. So that will be F1. Then we need to get F2. That is the frictional force on the caravan. This is the frictional force on the breakdown track. So with that, let us now get the frictional force on the caravan, and the frictional force on the caravan will be equal to that. That is the frictional force on the caravan. That will be mu R2, and our R2, that is M2 times the acceleration due to gravity, and that is what we shall get. So from that, you will be able to get the total frictional force. The total frictional force, of course, it will be this plus this. That will be the total frictional force. Then after getting the total frictional force, now you can get the net force on the whole system. So what will be the net force on the system? It will be getting this minus the total frictional force. So it will be same as getting 3000 minus F1 minus F2. So if you have already got F1 plus F2, so you get 3000 minus the total frictional force. So that will be what we call the total resistive force. So the total resistive force, we have got F1, we have added there F2. So what will be the net force? So that is the resultant force on the whole system. So that will be the driving force. Then subtract what we call the total resistive force. And what you get here will be what we call the net force. So this net force will be the force that will be causing the movement. That will be the force that will be causing the movement. So that's why we shall be saying that that net force will be same as MA. So that will be same as MA. That is from Newton's second law. So it will be same as MA. And for that case, our M, remember, is the combined mass. We are looking at the system. So that is the combined mass. F net, that is the net force. And the net force, we have got the driving force minus the total frictional force. So when you do that, you should be able to get 648 divided by this. So what should this one be equaling to when we put this to 4 decimal places?
It is the same as that.
It is same as that.
Yes.
Okay. So
it's the same.
Okay. So it means this will be our acceleration. So we needed the acceleration at the required task, the acceleration of the towed system. So it means we shall be saying that the acceleration of the towed system is, in conclusion, the acceleration of the towed system is 0.324 meters per second squared. So that will be the acceleration of the towed system. Then part 2 requires us to find the tension in the tow bar. Now, in the tow bar there is tension. In the tow bar there is tension. So when we want to get this tension here, then we consider with respect to the caravan. We consider with respect to the caravan. So this is what we shall have. This is what we shall have. We are saying for the tension in the tow bar, we shall consider the caravan alone. So the force is acting on the caravan. So the force is acting on the caravan. We shall have, for that case, the tension in this system, and what we call the frictional force. That this is the frictional force opposing the motion of the caravan. So it means it will be T minus F2 equaling to MA. So that is how we should be able to get what we call the tension. So we are saying that force is acting on the caravan. We have the tension which is acting forward, the frictional force, which is acting backwards. So when we use the second Newton's law, then we should be able to get tension minus the frictional force equaling to MA. But the M we are using is M2, that is the mass for the for the caravan. So it means we shall have T minus this equaling to 800 into that. So when you look at that, you should be able to get your answer as T equaling to 1,200 newtons. So when we look at the task again, they are saying use your findings to determine whether the tow bar will safely manage the trip without snapping. So they told us that the coupling tow bar connecting the breakdown track to the caravan is designed with a safety threshold and will snap if the tension force exceeds this one here. So if the tension exceeds this, then it will snap. And for that case, for us to give the conclusion, then we need to look at to compare the two. So this is 1,200, and the maximum allowable tension is 1,250. So when we look at that, you realize the calculated tension is basically less than the maximum allowed tension. So for that case, it means that the tow bar will not snap and can safely complete the trip. So that will be the conclusion for that case. Looking at the next part, they are saying shortly after they depart, Mr. Rusoke sets off from his home. In his private car to follow the recovery team to the garage. From a stationary start, he accelerates at a constant rate of 2 meters per second squared for 10 seconds, and then he maintains the maximum speed attained for the next 5 seconds, and then applies his brakes to decelerate uniformly to a stop at the garage entrance in a time of 2 seconds. So that will be our next part. So this is our next part, and that will help us to answer the task, which is sketch a velocity time graph representing Mr. Rusoke's journey. Use your graph to calculate the total distance from Mr. Rusoke's home to the repair garage. So that is what we need to look at. Now, let us see how best we can answer that. So we need to look at the velocity time graph, and of course we talk about the distance traveled. So we are told that Mr. Rusoke set off from his home in his private car to follow the recovery team to the garage from a stationary start, which means that U is at the start U is 0. That is a stationary start. Then he accelerates at a constant rate of this for 10 seconds. So he accelerates at this for 10 seconds. So if that is the case, then it means we can get the velocity, the maximum velocity or the final velocity for which he attained. So since we have initial velocity, we have acceleration, we have the time, so we can go on and obtain what we call the acceleration. So what will be the velocity, not acceleration. So we shall obtain the final velocity. Now, what will be the final velocity? So we shall use the first law, which says that v is equal to u plus at. So our u is 0, so we have 0 plus 2 times 10, and from that we shall be able to get our v as 20 meters per second. So that will be the final velocity that he attained. Now, if we attained that velocity there, then next we need to look at we are told that he maintained this maximum speed for next 5 seconds. So the car traveled at that constant speed of 20, which he attained and that was maintained for the next 5 seconds. So next, we are again told, when you look at the information that we have, that he brakes. He then applies his brakes, decelerate uniformly to a stop at the garage entrance in a time of 2 seconds. So he decelerates from 20 to 0 in 2 seconds. So when we look at that, then we should be able we should be able to come up with this kind of graph. Should be able to come up with this kind of graph. So we are having our velocity is starting from 0, and after starting from 0, he accelerated for he accelerated at 2 meters per second squared to attain a maximum velocity of 20, and that was done in 10 seconds. So that is why we are having from here up to here, that is up to the maximum velocity, which is 20 in 10 seconds. And then again, he maintained that speed, that is, he maintained 20 meters per second for the next 5 seconds. So if this is 10, then the next 5 seconds will reach when we are at 15. So for that case, we shall have that. So that is at this given point. Then next, he applied the brakes and decelerated in the next 2 seconds. So that's why we will come up to 17. So from that, we shall now have this as our sketch. So next, we need to look at the total distance traveled. So how do we get the distance? If you have this, distance is same as the area under the velocity time graph. So if you get the area 1, you add the area 2, you add the area 3, and then you'll be able to get the total distance. So that is what we are doing. We are considering these different areas. Area 1, when you look at this is right angle triangle. So you can apply area of a triangle, that is a half times base times height. So looking at that, we are having half times base times height. So this is your base, this is your height, which is 20. You'll be able to get area 1. So this next, you have this area 2, that is a rectangle. So you also use length times width. Then this one is also a triangle. You can as well do that. So from there, you will be able to get the total distance. So finally, you have the total distance. That is the total distance from Mr. Rusoke's home to the repair garage. So you must put the conclusion. So therefore, the total distance from Rusoke's home to the garage is 220 meters. So you conclude with that. Therefore, the total distance from Rusoke's home to the garage is 220 meters, and that will be the required answer. So that is how best we can get the total distance, and possibly that will mark at the end of our paper 2. Yes, please. Someone has a hand up.
Sir, I was requesting that you go a bit on how you have obtained the tension there up.
Up.
Yes.
Okay. Here.
Yes. Let me see. I don't know whether I'm the one who is a mistake, but I'm not getting the.
What are you having?
I'm not getting the answer. Yeah, I'm having 3 points.
What do you consider?
Oh, I have seen my mistake. For me, I had the 8,000.
Okay. Instead of 800.
Yes.
Okay. So that is all about paper 2. So the paper 2 is completely destroyed. So otherwise, that is where we shall stop. That is the paper that we surely had wanted to discuss. So next, we shall be able to start with another paper now. Possibly, actually, we have not yet covered the paper for Achieteka, that is paper 2. So we shall also go through the Achieteka paper 2. We also get that one done. And let me see, do we have any other mock papers that have been done so far? I've seen, is it Wakata? As if work is done so far. Yeah, so possibly we shall also look at how we can go through it as well. So someone has a hand up.
Yes, sir.
Yes.
And so me, I have a problem like in interpreting those scenarios. Sometimes I get difficulty. I don't know what I should do. But when there are direct questions, at least I can do something.
Okay. So with the interpretation, actually what you can do is to look at different items. More items you look at, more you get the idea on how items are asked.
Okay.
Yes, because I cannot surely say that that is the general problem. But the more you try questions, the more you try the questions, when you are reading, the more you get the idea on how the items are set.
Okay, thank you.
Yes, please. So try as many items as you can.
Okay.
Okay, please. So in case there are no any other questions, please, that is basically where we shall, as far as our paper is concerned. Yes, I can't run now.
Sir, I'm still taking back. Mr. A.
Yes.
On item, it was item 3. No, yes, item 2.
This one.
The one that we did. Yes, that.
Okay.
We are supposed to calculate for correlation, and then after for random samples.
Okay. I think
Yes,
it was this.
Yes. So when we are doing that party, it was part B, where we had the probability of x equaling to x. There is somewhere where we substituted in a coefficient, so like a b into x minus 12.
Yes. Let me take you there. Okay. This was done.
Yes, that was done.
Here.
There. So I don't know why you substituted. Why you tried to involve in those coefficients of a and b.
Okay. So the reason why we did that, let me take you back to the question. The question is actually the scenario was for x equaling to 15, 18, 17, the probability of getting x defective bulks is proportional to x minus 12.
Yes.
Okay, is proportional. P of x equaling to x is proportional to x minus 12. But this happens for x equaling to 15, to 16, and 17. Now, when you are to remove the sign of proportionality, then it means you put a constant.
Yes.
So this is for that. But also they are saying again the same probability is proportional to this, and this one is for x equaling to 18, 19, and 20. So we cannot use the same proportionality because these are for different values.
Yes.
So here we are using again the same because they are telling us that the defective bolts were picked from 15 to 20, but he realized that the probability of getting x here was proportional to this here, and then for this one was proportional to this. So here we have another constant of proportionality because it is also proportional to this.
Yes.
Yeah. So that's why we had these two. So this is A into this is B into that.
Yes.
That is why.
It is okay.
Okay, please.
Thank you.
All right. So basically that is where we shall stop. That paper is complete. Shall be able to meet, and we shall be looking at now other papers, possibly paper 1 and paper 2 at the same point. So we shall see which one will be done by then, and that is the one we shall be able to start with. Yes, stay son.
So I'm kind of requesting maybe if you can send us the soft copy for this paper which I've done here, so that you can try out some numbers maybe in free time.
The soft copy is already in the group.
Oh, I think you should tag me to it.
Oh, maybe I will try to resend it again.
Okay, thank you.
Okay, please. So, we shall have this one here posted in the group, especially on our drive, so you can always refer to it. So, members, that is where we shall stop, and basically come to the end of our today's program. It was basically to complete the paper, and that is what we have done. So in case you missed that, please make sure next time you are there, so you cannot be left behind, because we have gone through everything at the moment. Yes, your hand is up, Bruce.
I was requesting, but I wanted to know whether the other listeners you had posted them in the drive, because I tried to check there last night. I didn't find them.
I'm going to put them everything. I'm going to put everything there now.
Okay.
Okay, please. Okay, nice time.